All right, so very good morning to everyone. A very good morning to all of you. Hello, Bala. How are you doing? So, guys, in this session, what we are going to do. So, first of all, my name is Dr. Umashankar. I am your physics educator. And in this session, what we are going to do? In this session, we are going to have a complete revision of vectors. So, on this channel, we already have completed the vector. Okay. So vector we already have completed, but in this session I'm going to have a one short session on which I'll be discussing everything about the vector. Okay, so yeah, Bala, good morning. So basically what we are going to do, we are going to have everything about the vector in this session. Okay, so it is sort of a revision session and it is going to be a one short session, one short destination for complete vectors. So we know that vectors are a very important topic because it helps you in kinematics. It is going to help you when you are going to deal with the forces. A lot of concepts are there in the vector, which is very useful. Okay, okay. Now let's have the starting of vector. So basically, vector is something which has three things. Okay, the first thing that it has magnitude. Okay, first thing is that it has. So I'll be covering. See, if you want to see the vectors in detail, you can see the sessions in the channel. Okay, each and everything about the vectors I have completed very extensively, very comprehensively. Okay, so in this session I'll be quite quick. I'll be taking up the things at a good speed. Okay, so basically vector is something we know that which has magnitude, which has direction, and also which obeys the laws of vector addition, which obeys the laws of vector addition. Okay, so what happens that the first two things, basically students have seen that they know the first two things, they you know understand the first two things, but they forget about the third thing, which is the most important thing. So if any quantity having the magnitude and direction doesn't make it a vector unless it obeys the laws of vector addition. Okay, so we'll be coming to the laws of vector addition. Okay, but before that, let's have some basic knowledge about the vector. So see, what is a vector? So vector addition, see, the whole thing is about the vector addition, vector multiplication. So for example, if there are two scalar quantities, you add them, you multiply them, you divide them, whatever you do with them, you will get a certain result. Like for example, if there is a vector, let's suppose there is a scalar quantity 3, you add 3 plus 4, you always going to get 7. Okay, okay, but if we are adding 3 vectors, okay, so any vector which we say the vector is 3, so it has some magnitude and some direction. So when you add 3 vector, 4 vector, you can get anything. There is no certainty you get the 7. You may get the 7 also. You may get 1 also. Are you getting my point? You may get 7 also. You may get 1 also. So in when you are adding two vectors, okay, it is not like when you are adding the scalar. And same for subtraction. Although there is nothing like vector subtraction, it is only addition. I'll be talking about it. Okay, so two vectors are added. It can give you the range of the values, unlike the scalar quantity. Similarly, if you multiply two scalar, you always get 12. But if you multiply two vectors, okay, then you have to first think that whether you are doing a dot product of it and whether you are doing a cross product of it, right? Cross product of it. So normally in a scalar what happens, so this is the sign of multiplication. Okay, but when we are doing the multiplication of a vector, you have to now think that whether we have to do the dot product, whether we have to do the cross product. But for like this thing 3 into 4, we sometimes also write like this, that 3.4, isn't it? Okay, you always get the same result, you always get 12. But in the vector it is not like this. You can get other things also, right? So we'll be talking about it also, like whether we are going to do the dot product, whether we are doing to the cross product. So this is something inside of the vector, that there are different laws. So the vectors do not follow the normal algebra, right? Normal algebra that we know that scalars are used to follow. I hope this is clear. Now, all this thing basically, in a way or other, depends upon what? It depends upon basically, if I say loosely, depends upon angle between the vector. Angle between the vectors. Okay. Okay. So whether you are getting what result of addition, what result of dot product, cross product, it in a way depends upon that what is the angle between the vector. What is the angle between the vector? Okay. So we'll be talking about the angle between the vector now. But before that, so any vector, we know it is represented by a line like this. Okay, so this we know, this is the tail. Okay, this is the head. Okay, and from tail to head, from tail to head, from tail to the head, this refers to the direction of the vector. Okay, let's suppose if I write that a body is moving at a velocity of 3 meter per second. Okay, in east direction, in east direction. So you would be representing this vector. So you would say that something is moving in east direction. That means this is to be represented like this. This is east, right? So from tail to head, this gives you the direction of the vector, and the length of this line gives you the magnitude of the vector, right? So we know it. Okay. So if you want to represent a vector, so we know this. So see, east, west, north, and south, right? So if any vector, so from tail to head, it gives you the direction. So this is east, west, north, and south. So what is going to be this? So this is going to be northeast, right? Whenever it is saying, it said that a vector is in northeast direction. So you are going to draw the vector exactly in the middle of north and east, right? Similarly, this is going to be what? It is going to be northwest or west north, same thing. It is going to be west south, and it is going to be southeast. And this angle is going to be 45. Every angle is going to be 45 because it is exactly in the middle. It is exactly in the middle. Now, if someone say that there is a vector, like suppose 3 meter per second, this is the velocity in the direction 30 degree north of east. Okay, 30 degree north of east. So how you are going to represent it? How we are going to represent it? Or if I say 15 degree in the direction 15 degree west of south, west of south, right? Or if I say 37 degree 37 degree east of north. Now, how you are going to represent it? Will you be able to do it? The live students, please answer me. Okay, so I'll tell you. See how we are going to do it. So first of all, east, north, west, and south. When we say that 30 degree north of east, so 30 degree north of east, what does that mean? That you start from north, make an angle of 30 degree, and moves towards the east. So this is going to be the north of east. Did you get my point? Sorry, north of east it is, na? So it will be like, so you start from east, north of east. So you start from east and go towards the north. So this is going to be 30 degree north of east. Do you agree? Yes or no? Yes, sir, absolutely. Now, when we say 15 degree west of south, that means you started the angle from south and you goes towards the west. So this is going to be 15 degree west of south, 15 degree west of south. And when it is said that 37 degree east of north, sometimes it is also written like this, EN, 37 degree EN. So that means 37 degree east of north. So start 37 degree east of north. Now what does that mean? So you start from north, you go by 37 degree, okay, towards the east direction. So this is going to be your vector. So if some data, if some information is given like this, will you be able to represent the vector? Will you be able to make the vector? Sir, yes, sir, most certainly we will be able to move the, show the vector, right? Okay. Now, one thing very important is to know that what is the parallel shift of vector. See, this is of utmost importance, okay, and it is used a lot. Very basic. Okay, so I'll be just giving you some things which help you. Ultimate aim is to do addition, subtraction, which is ultimately the addition only, and product of the vector, and knowing some basic phenomena, that is position vector, displacement vector, right? Now, to do that, we'll be using the parallel shift. To do that, we'll be using the parallel shift. Okay. Okay. So, what is the parallel shift? Okay. Now, please understand this. Let's suppose I am having a vector 30 degrees from here, and it is having a magnitude of 3 meter per second. That means it represents the velocity. Okay. Now, through parallel shifting, what I can do, I can make this vector anywhere parallel to this. Like if I want to make it here, the only thing that you have to remember that you cannot change the magnitude, that is the length of the vector and the direction of the vector. Are you getting my point? You can make this 30 degree over here. You can make it over here. Remember, this has to be 30 degree. Okay, wherever you make it, it must make an angle of 30 degree from the horizontal, right? Okay, like you can make it here also, you can make it here also, you can make it here also, but you can't make it like this. Are you getting my point? Okay, it has to have the same direction. That means it must have the same angle wherever you make it. Wherever you make it, it must have the same angle with the horizontal, and it must have the same magnitude. So one vector can be shifted anywhere where you want, provided you are not changing its magnitude, you are not changing its direction. I hope this is fine also. Okay, so this is what we call as the vector, parallel shift of the vector. Parallel shifting of the vector. And third important thing is angle between the vector. See, one is knowing the direction, north, east, east, west, north, south, all this. Second is the parallel shift. And the third thing that is you are going to use very extensively, that is the angle of the vector. That is the angle of the vector. And see, many students make a lot of mistake in this, because this is going to be helpful till the end of the vector. Everywhere in the vector, this is going to be very, very useful. Since, my dear, see, as I said, multiplication of a vector, addition, subtraction, all these things depends upon the angle of the vector, or angle between the vector, I must write. Okay, because when we are doing, see, ultimate aim is to do the algebra of the vector. Okay, angle between the vector. So for that you need to know, that what is going to be, Bala, I think it was going to take somewhat near 2 hours, 2 hour 30 minutes, somewhat like that. And also depends upon like how easily you grab the thing, right? So I'll be very quick in this session. I'll try to be quick. Okay. So angle between the vector. What is going to be the angle between the vector? So first thing that you have to do, always remember, though you have to connect two vectors. When you are seeing the angle between the vector, you have to connect the two vectors tail to tail. Tail to tail. So when you are telling the angle between the two vectors, you need to connect them tail to tail. This is the first thing. Like for example, there is a vector. Let's suppose this is a vector B, okay, and let's suppose this is a vector A, okay. Now, if I ask you what is going to be the angle between these two vectors, so sir, we know that we can do the parallel shifting. But the motion in 2D we are running, so that is not completed in the normal session. we have completed the projectile motion. Okay, projectile motion is also yet to be completed. One session is left for projectile motion, and two sessions will take for the circular motion. Then motion in 2D will be completed. Motion in 1D is completed. Two sessions are left in motion in 2D. Okay, so just I wanted to have a one-shot session of vectors, so that because see vectors we have done in so many sessions, because very comprehensively we have done understanding each and every aspect of it. So I wanted to have a one shot so that students can see everything of vector in one session only. Okay, quite quickly, right? Because see afterwards, I think within this week, like from Tuesday, Wednesday, I'll be starting with the Newton's law of motion. Their vector is extensively used. Are you getting my point? No, no, Jan it won't be possible. I'll try to complete by the end of the March. Okay. And also see chemistry educator is also coming. Okay, so he'll be also taking some classes, right? Acha, acha. Okay, you watch one day. Thank you, Bala. Okay, so let's continue, है ना? So now I can do the parallel shifting, right? I can do the parallel shifting. Now I can take A towards B or I can take B towards A. Doesn't matter. But the only thing that you have to be careful every time, okay, that is the angle between the vector. Are you getting my point? Like you have to connect them tail to tail. Because see, angle you will be requiring in the products of the vector also. Everywhere, everything you will be requiring. Everywhere in the vectors you will be requiring the angle. So don't forget that the angle between the vector is when you connect them tail to tail. So if I take this vector here, if I bring this B here, I connect them tail to tail. Okay, it would look like this. I can take A also there. That doesn't matter. Now, please understand this. So, this is the angle between the vector. Let's suppose this is 30 degree. Let's suppose this is 30 degree. Are you getting my point? Now, please understand this. When you are connecting the vector tail to tail, when you are connecting the vector tail to tail, basically the smaller angle. So, this also can be the angle between these two. Now, you can take the angle between this also. So, remember, this is not. So, this would be 330 degree. So, remember, this is not the angle between the vector. The angle between the vector is the smaller of two angles. Remember, it is the uh Bala, in the evening now at today 7 p.m. I'll be having a live session. There I'll be giving you all the we'll be talking about this, that how you are going to complete the syllabus in the next month. What shall be your approach? Are you getting my point? Okay. At 7 p.m. today. So will it be fine if we talk about all this in 7 p.m. session? What do you say? Because see, we came up with the specific session live only. Okay, so there I'll be taking up all these questions and we'll be discussing it according to yours. Okay, because see, what I believe, see, one teacher can say anything, but ultimately it depends upon you, how you are proceeding. Like you said, na 7 chapters you have completed till now. So what should be your approach? So we'll have a live session. You can ask me anything in that at 7 p.m. today. Right? Sounds good. Okay, so let me come back to this point. So important thing is that when you are connecting two vectors tail to tail, you have to take the smaller of the two angle. Remember, a smaller angle. Okay, a smaller angle. So when you connect the vectors tail to tail, it will you can see two angles between the vector, but you have to take the angle which is smaller, right? Like for example, 30 degree. Like for example, 30 degree. Now tell me one thing. What is the angle what is the angle between these two vectors? If I say this is A, this is B, and this is 60 degree, what is going to be the angle between them? These two vectors, can you tell me? What is the angle between these two vectors? And if I say like this, vector C, vector D. Okay. What is going to be the angle between these two? So what is it going to be? So sir, are they connected tail to tail, sir? No, sir, they aren't connected tail to tail. So for that, what you have to do? So the you have to connect them tail to tail. So I can take this B there or I can take this A there. Okay. So if I take this A there, if I take this A there, so I can start. So if I do this A, if I do this A, if I take this A here, do you think that this is the parallel shift and now these two vectors are connected by tail to tail, right? So tail to tail, so this is going to be also 60 degrees. So here the angle between two vectors is going to be 60 degrees. Is it fine, madam? Please answer me. Do you agree? Yeah? Alternate angles, no? Right? Is it going to be the alternate angle thing? We know na alternate angle, corresponding angle. So this is the alternate angle, right? Understood? Please tell me. Okay. Now you please tell me the angle between this C and D. See what I am trying to emphasize here, that what angle when you are seeing between two vectors, whenever you are seeing the angle between two vectors, you always have to ensure that they are connected tail to tail before you tell them the answer. Right? Please give me 20 degree. Very good. So very simple. So they aren't connected tail to tail. So they are not connected tail to tail. The first step that you must do, you must connect them tail to tail. So for that, I can shift this D vector parallelly. So if I shift this parallel here, so this is going to be the D vector now. This is going to be the D vector now. Now this is 160, so this has to be 120. This has to be, sorry, this has to be 20 because the angle that a line makes is always 180. So 180 minus 60, this is going to be 20 degrees. So the angle between the vectors C and D is going to be 20 degrees. Is it fine, madam? Please answer me. Wonderful, sir. This is fine only. Okay. Now, another important thing is types of vector. Okay. These are the basic of vectors which one must know in order to do good into vectors. But we are not going to see it now. We are going to see it with their uses. Like if I tell you unit vector now, what happens when you are going to see the use of the unit vector, you are going to get confused. Okay. So I'll be covering this along with the session, right? Wherever we need what type of vector, we are going to cover into it, right? Okay, very, very simple. Now let's proceed. So let me come to the very important context. Let me come to the very important context, that is the vector addition. Okay. So you will be using this thing, vector addition, in kinematics. You will be using this thing in, like in whole of the physics, one way or another, this is going to be very, very helpful. Okay. So vector is something very important. See what happens in physics, that we start reading the chapters, but we don't know the basics. So if you don't know, if your basics in physics is weak, okay, trust me, you are never going to feel confident in this subject, right? Because the chapters are very interconnected, right? Like you see that this is the mechanics. That mechanics, if you know the mechanics, you will be going to learn electricity very easily, right? Because more or less it is sort of the same thing only, right? That is also a part of mechanics, I believe. That we'll talk about it. So now talking about the vector addition, okay? So there are two ways. One is graphical, okay, and one is analytical. One is analytical, okay. And basically, when we are talking about, so see, if there are two vectors, when you are adding two vectors, so basically you are going to use these two things, law of triangle of vectors, right? And secondly, law of parallelogram. Law of parallelogram of vectors. Okay. Now, law of triangle of vector is basically graphical. Okay, but very useful. Are you getting my point? Sometimes law of parallelogram of vector is going to be a lengthy option to solve a question. Okay. Although if you want to do the addition of two vectors, and that addition is nothing but subtraction also, I'll just show you in a while. So when we are talking about the two vectors, the first thing law of triangle, second is law of parallelogram. Okay, law of parallelogram. So law of parallelogram is both graphical and analytical, right? So see, what is going to be our aim for time being in this session? That see, if there are two vectors, ultimately we want to get the results. Okay, that what is the resultant of these two vectors? So when I add two vectors, I can be using these two. Okay, and there is a third, that is law of polygon of vector. Law of polygon of vector. Okay, so this is completely graphical. Okay, this is completely graphical. Okay, although we can use some simple geometry to sort the answer, but our focus will be on law of triangle and law of parallelogram for time being. Law of polygon is basically graphical. I'll tell you about it also. Now, first thing is this. Now, please understand this. I have two vectors. A vector. I have two vectors. Let's suppose A vector and there is a B vector. There is a B vector. Now I want to do the addition of these two vectors. I want to do what? I want to do the addition of these two vectors. Okay. Now first thing, I have to choose whether I have to go with the law of triangle. I have to go with the law of parallelogram. Okay. So I'll give you one tip here. So whenever you see that angle between, if angle between, if angle between two vectors is 90 degree. Okay, if the angle between two vectors is 90 degree, you go by the triangle law. It will be giving you very easy result. Okay, very quick result. Okay, okay. So if angle between two vectors is 90 degree, you always can use triangle law. Although if angle between any two vectors is not 90, also you can use the triangle law by using some sine or cosine rule. I'll be telling you about it. But first of all, let's see what is the process. Now, please understand this. In the triangle law, see, we have these two vectors. First, we are going to do the triangle law. Okay. So, very simply, what is the triangle law? So, for triangle law, you have to do. So, what is the triangle law? First, so the triangle law says, what does the triangle law say? Can you tell me? So, triangle law says, so I'll just do one thing just to save some time. I'll do one thing. So I have copied it and pasted it from the notes. Okay, because we already have done this now. I'll just take it to the next page. Yeah. Okay. So I want to connect the two vectors by the triangle law. So what does the triangle law say, Sveta? Triangle law of vector addition. See, very simple. So it says triangle law of vector addition of vector addition. So what does this say? So it says if two vectors are given by two sides of a triangle in magnitude and direction taken in the same order. Remember, taken in the same order, then the resultant is given by the third vector taken in the opposite direction. Okay, so see, very simply, we had the two vector. Let's suppose this is A vector. Let's suppose this is your A vector, and we have a B vector, and we have a B vector somewhere here. Okay, okay. Now what you have to do, you have to make a triangle in such a way that the two sides of the triangle is given by these two vectors. Now two and taken in the same order. See, same order means that had two tails. Okay. So in triangle law, you have to connect the vectors head to tail. See, A vector head connected with the tail of B. Okay, this is what is written. So if two vectors are given by two sides of a triangle in magnitude and direction taken in the same order. So if let's suppose these two are taken in the same order, okay, because this is head to tail connection, then the third side of the triangle, what is going to be the third side of the triangle? This is going to be the third side of the triangle, right? So the third side of the triangle is going to give you the resultant of these two vectors. What does you mean by the resultant? So when you are adding up, when you are adding A vector and B vector, when you are adding A vector and B vector, you are going to get another vector, that is your R vector. Okay, and for vector, see, remember, if there is a vector, you require two things about it. One is its magnitude, another is direction, right? So when you are using the triangle law, the third side of the triangle taken in opposite order, okay, so that means that you are connecting the tail of the first vector. See how you get this R. See, tail of first vector, okay, to head of second vector, head of second vector. So when you are joining like this, okay, so if two sides of the triangle is given by the given in magnitude and direction of giving the magnitude and direction of two vectors taken in the same order, then the third side taken in the opposite order is going to give you the resultant. Are you getting my point? So this is going to be your resultant. Is it fine, beta? Please answer me. बताइए बताइए. Now if I say something like this, now let's suppose this is 3, let's suppose this is 4, okay, and let's suppose this is x, okay. So now what is the resultant in this, and what are the two vectors? So how you are going to write it? So if you are going to write it like this, 3 plus x is equal to 4. See, very useful, okay. See, very useful. 4 plus x is equal to 3. 4 plus 3 is equal to x. 4 plus 3 is equal to x. Okay. So, or none. Okay. Or let me tell you. So this is A, this is B, this is C. Now, which is going to be the correct hit in this? Which is going to be the correct in this? Can you answer? What is going to be the correct here? Can you answer, Mira? Which is going to be correct, sir? C is going to be correct, sir. How come, sir? Now see, this is a triangle. Now see, these two sides are in the same order, and this is in the opposite order. So this is the resultant. This is the resultant. Understood, beta? This is the resultant, right? Wonderful. Okay, so you got this point. Now, if there are two vectors, let's suppose this is A vector and this is B vector. This is B vector. Okay, and let's suppose this angle is theta. Now, how you are going to find the resultant of it? So, I want to have A vector plus B vector is equal to, let's suppose, R vector. So, I want to have the direction and the magnitude of R vector. So, how you are going to do it from the triangle law? So, I'll tell you, see, very simple. See, sir, Sir, right now, sir, they are giving the two sides of the triangle. They are giving the two sides of the triangle. Okay, but but they are not connected. They are not right now connected tail to tail. So they are not giving the two sides of the triangle in the same order. For applying the triangle law of vectors, the vectors are to be connected head to tail. Remember, that is why it is also known as head to tail method, right? Head to tail method. So what you have to do, sir? So I'll have to do some parallel shifting. So let me parallel shift this A here, and if I parallel shift this B from where this A ends, okay, or you could have parallel shift A, doesn't matter, that is also fine. Okay, so this is going to be, and this angle is going to be theta again. This angle is going to be theta again. Now you are going to have to complete this triangle, but the direction will be in the opposite order. So this is going to be your resultant, right? This is going to be your resultant. Is it fine, beta? Please answer me. Bole. Working fine? Right? So did you get the law of triangle? Right? Now please understand this. Now please understand this. I'll tell you something. Now if two vectors, let's suppose two vectors, one vector is this and one vector is going like this. One vector is going like this, or one vector is going like this. Okay? Going like this. Okay? Okay? And there is another vector, let's suppose D vector is there. Okay, now you want to do what? You want to do A vector plus B vector. You want to do the A vector plus C vector. You want to do D vector plus B vector. You want to do D vector plus C vector. So how you can interpret it in terms of the triangle? How you can do it? Can you please try it? I'll just show you. I'll just show you. You don't worry. See, what we can do, sir, we want to find A and B, A vector and B vector, A vector plus B vector. So what we can do, sir, we can do some parallel shifting. So this is going to be A vector, okay, and this is going to be the B vector. Remember, the length is giving the magnitude of the vector. Okay, so what is going to be the R vector in this first case? So this is going to be the R vector, isn't it? Okay. See, two sides of the triangle in the same order are giving the two vectors. Okay. Then the resultant is given by the third side. Understood, beta? Now, this is a right angle triangle. This is a right angle triangle. So you can use the algebra of a triangle. Can we write R square is equal to A square plus B square? Isn't it? Hmm? Please answer me. Very easy to use in the case of right angle triangle. Very easy to use. And this is, let's suppose, theta. Okay, so this is, let's suppose, theta, or let's suppose alpha, because theta we are using angle between two vectors now. So if the angle between A and B is 90 here, it is 90 of course, because if you shift B also and connect A and B tail to tail, then also it is going to be 90. So if I want to find the alpha, I can do tan alpha is equal to perpendicular upon base, isn't it? Trigonometry of a right angle triangle. Very, very simple. Now, similarly, if I want to do with A and C, I can parallel shift A and C. If I parallel shift A and C, what is going to be the R? This is going to be the R vector, isn't it? This is going to be the R vector. Okay. But now here, see, resultant is going to be, in this case, what is it? Sir, R square is equal to A square plus C square. So this way you get the magnitude of the resultant. And what is going to be the angle? What is going to be the angle? So this is going to be the angle. Okay. But this is going to be into the fourth quadrant. Okay. See, remember, don't get trapped into all this. Okay. Whenever you are seeing a vector, there are two things, magnitude and direction, right? So you have to see whether the direction is going to be same or not. Are you getting my point? Okay. B sine theta upon A plus B cos theta. So this is going to, see, this is what you are using the formula from the parallelogram. Do we need to use this formula here? You tell me that, Bala. See, what is our aim here? And all the other students, welcome to the session. What is our aim here? We want to save some time also, na? In this case, when that is the right angle triangle, do you need to use this formula? Please answer me. Hmm? That is the analytical parallelogram law standard formula that you are telling me. But do we need to use that? If at all you are going to use that, you are going to get the same thing. Are you getting my point? See, B sine 90. Sine 90 is 1. upon A plus B cos 90 is 0. So again, you will be getting B by A. See, in the examination, we have to save some time also. Are you getting my point? Okay. So if two vectors are having to be perpendicular, now for example, if I want to see D vector, B vector, so D vector, let's do some parallel shifting. This is D vector, B vector. Now, do I have connected them rightly for the triangle law? No, sir, you have connected tail to tail. So this is not going to be the right connection. I shall connect D here. Okay, head to tail. See, head to tail. So what is going to be your resultant direction? This is going to be your resultant. B and D vector when connected. This is going to be your resultant. Do you agree or not? Do you agree or not? So if you are asking the angle from the X, so this is going to be alpha in this case. Do you agree or not? Please answer me. Okay, and this is going to be your resultant. Again, you can use this. R square is equal to B square plus D square. Now, will you be able to deal with it or not? Please answer me. Will you be able to deal with it or not? The triangle law. So when it is 90, no, you used to do, so that is fine only. See, that is fine only. But you can see in the, see, this is what is the problem, Bala. See, we waste a lot of time. If we have this small things in our mind, if we keep this thing in our mind, we can save some time. And if the time is saved, you will be more confident in the examination. You will be using this time to do, some better questions. Like if some questions, so some questions will take some more time, right? So you can give that time. Otherwise, the pressure is starting to build up. Okay, let's try to do this question now. Let's try to do this question. I'll just give you the options. See, I'm not saying you can't do by the analytical method. Normally, this happens that we go by the formula and we end up doing the calculation and wasting some time. Can you please try it? Let's try this question. Please go for it, beta. I'm very sure we can do. What is going to be the correct option? Let's try this. See, I give you one more information just before you do this question. See, there is a standard triangle. Okay, this 37, 53 degree. Just have this trick. So if this is 3, this is 4. Just you memorize this thing. Okay, this is going to be 5, of course, because Pythagoras. Okay, and the angle here is going to be 37. This is the standard. See, now if this is 4, this is 3, this is going to be, so you remember this 4-3-5 triangle. Are you getting my point? This is going to be 57. Remember, memorize this 53 degree. Okay, beta? Okay, do memorize this. Okay, do memorize this. Okay, this is going to helpful a lot. Okay, so now it says a boy moves 3 meter east. Okay, 3 meter east, then took 90-degree left and turned and moves 4 meter towards the north. So it moves 4 meter towards the north. Find the displacement. Now please understand this. You could do it this question by the parallelogram also. Sorry, a square plus b square plus 2ab cos theta root over all of it. But do you understand that this is going to take a lot of time, right? So what we are going to do here, we can do it if we know the triangle law. So this is two are connected, the head to tail. Okay, head to tail. So these are two sides of the triangle giving you the same, giving you the same, right? Giving you this same thing. Are you getting my point? Okay. So now what is going to happen? This is going to be your resulting. The third side of the triangle is going to give you the resultant. So what is going to be the displacement? This is resultant is going to the displacement. So this is obviously going to be 5. Now what is the direction? What is the direction? So this is going to be 53 degree. 53 degrees. So it says east of north. It says east of north. So this is 50 degree north of east now. Because this is east, right? This is east. So this is 53 degree east of north. Are you getting my point? Sorry, it is 53 degree north of east. This is north, na, this is east. So 53 degree north of east. So it is basically 37 degree east of north. So this is going to be your B option. Don't get trapped into east north thing, right? Will you be able to do it? Yes, sir. Of course, we'll be able to do it. Now let's talk about the law of parallelogram. Very important. Actually, I'll give you one more trick. Now, so what if, so see, my point is whenever right angle triangle is there, you can look for law of triangle also. Okay. Now, let's suppose this is A, this is B, and this is going to be your R. Of course, this is going to be R. Right. So, sir, can't we apply the law of triangle? So, sir, yes, you can apply. And this is also going to be helpful sometimes. Let's suppose this angle is alpha, this angle is beta, and this angle is gamma, right? This angle is gamma. So you can use the sine rule here. What you can use? You can use the sine rule here. So the sine rule is very useful. It is going to be a very helpful to you when you will be dealing with the forces. Lami's theorem. Lami's theorem is the outcome of it only. Now please understand this. See how we are going to do the sine rule. So A upon, see, when you are seeing the A vector, you are going to take the angle between the remaining two. So the angle between the remaining two, that is R and B, is beta. So you can write A by sine beta. Then when you are writing B vector, B upon what it is going to be, what is the angle between the remaining two vector of this triangle? So R and A. So it is going to be sine alpha, and then what is going to be the r upon sine. So what is the angle between the other two vectors? That is a and b. Okay, so here you don't have to see whether the vectors are connected tail to tail or head to head. You just have to take the angles in the triangle. So this is going to be your sine rule. So this way also you can find the vectors or the relation between vectors. Understood? So in the cases of forces, at times this is going to give you a very quick result. Like for example, if it says that there is a force here that is 10 Newton, there is a force here that is 10 Newton, there is a force there, like let's suppose 15 Newton, and there is a force, let's suppose 30 Newton. I'm taking just some example. Okay, and let's suppose this angle is 30 degree. This angle is, okay, let's suppose this angle is 30 degree. This angle is 30 degree. Now you have to relate, you have to, let's suppose this force is x. So you have to find this x. Okay, you have to find this x. Okay, or just give me a moment. Yeah, so I'll just make it like this. Okay, and now it says this is x, this is y, this is 10, this is 30 degree, this is 30 degree, this is 60 degree. Now you need to find x and y. Now you need to find x and y. So see, you can use this thing here very quickly and can find x and y. How I tell you. So first sort out the angles between everything. So this is going to be 90, this is going to be 90. If this is 30, this is 60. If this is 60, this is 30 degree. This is 30 degree. Okay, this is 30 degree. Are you getting my point, but please answer me. Okay, okay. Now see, now see how it is going to happen. How it is going to happen. So see, you can take it in the form of triangle. I'll give you a trick. You can take it to the form of triangle. You can connect 10 with then x, then y. So y will become the resultant. So that way, one way you can do. But another way is if you apply the sine rule, Lamy theorem. Lamy theorem is the outcome of sine rule. See, very, very simply. There are three vectors, 10 x and y. 10 x and y. Now I'll write 10. Now what is the angle between the other two vectors? That is x and y. So this is 60 by 90. Okay, that is going to be sine 90, isn't it? The angle between x and y. So when you are picking up one vector, you need to see the angle between the other two vectors. Are you getting my point? Simply. Okay. Now this is going to be y upon. Now what are the other two vectors? So x and 10. So this is going to be sine 120. This is going to be sine 120 and then x upon. So what is the angle between the other? This is sine 150. Sine 150. Very, very simple. No? Very, very simple. Now this way, can you find the x also? Can you find the y also? Isn't it? Do you agree or not? Please answer me. Please answer me. So sometimes see this way you can save a lot of time. Understood, Buddha? Understood? Any issue in this? Is it clear till this point? Right? Now I'll move. So first tell me that is this clear up to this point, right? Right? Am I right, Buddha? To all the live students, clear. Wonderful. Okay. Now let's come to the law of parallelogram of vectors. The law of parallelogram of vectors. Okay. Okay. So law of parallelogram. Now this is what we are going to use. So this is having a high use case. Okay, because this is an analytical method, so you'll get a formula also. Okay. Now see, what does the law of parallelogram of vectors say? So if two vectors are represented by two adjacent sides of parallelogram in magnitude and direction, then the resultant is given by the diagonal of parallelogram in magnitude and direction is starting from common intersection of two vectors. Right? Very simply. Okay, this is the statement. This is the statement of law of parallelogram of vectors. So if two vectors are represented by two adjacent sides, so to form two adjacent sides of a parallelogram, the vectors must be connected. How? They must be connected tail to tail. Okay. So in parallelogram law, you need to connect the vectors from tail to tail, unlike the law of triangle or law of polygon, right? So if there are two vectors, let's suppose we are having a vector A here, we are having a vector B here. Now you need to apply the law of parallelogram. So how are you going to do it? So firstly, you need to connect them tail to tail. Now, if you are connecting them tail to tail like this, if you are going to connect them tail to tail like this, right? Then you complete a parallelogram. Okay, so first connect tail to tail. So in parallelogram law, you need to connect them tail to tail, right? Tail to tail. So vectors are connected tail to tail in parallelogram law. Then you do what? You complete the parallelogram. You complete the parallelogram. Now the diagonal. Now the diagonal which starts from the common intersection of these two vectors. Okay, that starts from where these two vectors are connected. That is which starts from these two vectors are connected. So this is going to be the resultant. So whenever you are applying the law of parallelogram of vectors, okay, law of parallelogram of vectors, so two vectors if connected tail to tail, then the diagonal which comes out from the common intersection is going to give you the resultant. Is it fine, Bida? Is it fine? Understood? So this, if you are able to find the magnitude of it, on direction of it, right? This is alpha, magnitude of it and direction of it, you will have your resultant. Now, what is going to be the magnitude? So you can do it like, for example, you can do it, for example, you can do it through graphically also, you can do it through what? You can do it through formula also. Okay. So I'll just tell you the formula now. Okay, so we can have it derived. If you want to see the derivation, you can see the session on vector addition on the channel. Okay, so see what is going to be the resultant. So resultant is square. If you derive it, we remember the formula, sir. It is going to be a square plus b square plus 2ab cos theta. 2ab cos theta. So this will give you the magnitude. Now remember one thing that normally students I have seen that they skip and do not apply at the right time. See here when you are using this formula, A, B are the magnitude of the vector. In this formula, you are taking up the magnitude of each of the vector. Now from this, I have written a square here, then I have done under root also. So I'll write R is equal to root over a square plus b square plus 2ab cos theta. And very important thing is that here in this we are using the magnitudes. Here we are using the magnitudes of a and b. So here only the magnitudes of the vectors are given. Okay. Now if we want to have this alpha, see that is the formula that you have used lastly now. So tan alpha, see how we are going to write it. How we are going to write it. Now see, remember, see, you can memorize this formula. How you can memorize this formula? So tan is ultimately sine upon cos. Sine upon cos. So remember, it is going to be, so this, see, alpha, you are seeing this alpha, you are seeing this angle from a vector. So when you are seeing this vector from a angle, what you are going to write? So you will be writing b sine theta, then a plus b cos theta. So there is a pattern. So if the angle you are seeing of the resultant from a vector, you are going to keep it alone in the denominator and you are going to use the sine and cos with the other vector in both numerator and denominator. So this way you can memorize it. So if you want to have the alpha, let's suppose this is beta. So this is beta. So how you are going to write tan beta? See, same pattern. This beta it makes with b vector. So when you are writing with the b vector, keep b alone. Then it is going to be a sine theta upon a cos theta. So this is the analytical way. So many students follow this blindly, right? They don't think to save the time, right? They just blindly use this. Are you getting my point? Please answer me. Right? Understood? Now, here I want to tell you one more thing. Okay? I hope this is clear to you now. This is clear to you. Definitely, sir, this is clear to us. This is definitely clear to us. Now, I want to tell you something. I want to tell you something here. Please understand this. See, when we say vector subtraction, okay. Now this way, so these two vectors A and B, these two vectors were A and B. So I have added them. So this is the resultant of this vector when I add A plus B, right? A plus B. Okay, so the resultant is R. Okay. Now, if I write for the same vectors, let's suppose I am having the same vectors, this is A and this is somewhere B. And now I want to do the subtraction of this vector like this. Okay. Then again there will be a resultant. Again there will be a resultant. Let's call it R dash just to make it different from what we have learned previously. Right. Now please understand this. So when we are writing A vector minus B vector, it is nothing but the addition of the vector. So how come, sir? How come? Now please understand this. And here you will come to know one type of the vector as well. So this is your A vector. Can I write it like this? Plus minus of B vector plus minus of B vector, and this is going to be the R dash vector. If I write like this, will there be anything wrong in this? No, sir. Now here I'll tell you one type of vector that is negative of a vector. See, negative of a vector. Now, what do we mean by negative of a vector? So, if a vector is given like this, let's suppose a vector is given like this, B, okay, and if you want to write negative of B vector, okay, negative of B vector, what you can do? You can simply reverse the direction. So, if a vector is reversed in the direction, very easy to understand. If a vector is reversed in the direction, keeping the magnitude same, you will call it negative of a vector, which itself is a new vector, isn't it? Because see, a vector is something having magnitude and direction. So if anything like magnitude changes or direction changes, the vector is a changed vector and it is a new vector, right? So negative of a vector is self a new vector. Are you getting my point? Right? Now please understand this. Now if I want to do this, so how we can do this? So now if I write, so this is A vector, this is B vector. So what is going to be the negative of B vector? Just simply reverse it. So if I do this A vector plus minus of B vector, can I write it like this? Please answer me. Because I have now reversed this direction and am about to use, I am about to use the negative of a vector, right? So, and I am about to use the law of parallelogram, so I have connected them tail to tail. Is it fine, beta? Please answer me. Right? Wonderful, sir. Now, can you see this is again the addition of two vectors? Okay, so how we are going to do it? Sir, complete the parallelogram. Complete the parallelogram. Okay, so we have completed the parallelogram now. And now, what is going to be the resultant? So this is going to be the resultant given by the diagonal, right? So this is going to be your R dash. Is it fine or not? Please answer me. Is it fine or not? Please answer me. Yes, sir. This is fine only. This is fine only. Understood, beta? No worries, sir. No worries. Right? Now, if you want to develop the formula, if you want to develop the formula between R dash, remember, given is, see how it says. So it says the angle between A and B, not angle between A and minus of B, not the angle between A and minus of B. So I'll do, so if given that angle between vector A and B, angle between vector A and B is theta. So if we say the angle between the vector A and B is theta, so basically this is going to be, so if I do this B, so if I take this B here, so now remember this angle is given now. Okay, this angle is given. Now if I want to make a beautiful formula out of this R dash, if I want to make a beautiful formula out of this R dash, of this R dash, how we are going to do it? Sir, theta is this. Theta is this. So what is the angle between A and minus B? So it is going to be 180 minus theta. So if I apply the law of parallelogram of vectors, shall I do like this? R dash is going to be, yes, it is going to be 180 minus theta. So see, magnitude of A, magnitude of B, plus magnitude 2 times magnitude of A, magnitude of B, and angle between the vector. So what is the angle between A vector and minus of B vector? So it is 180 minus theta. It is 180 minus theta. So we understand this, sir, we understand this, that the cos 180 minus theta, cos 180 minus theta is equal to cos theta. So this will become the formula. Are you getting my point? This will become the formula. Do you get it or not? Please answer me, beta. Did you get it or not? Now here very importantly, beta. Here very importantly, that the theta that you are using is not the angle between A and minus of B vector, that is negative of B, but it is the angle between A and B. Is it fine or not? Please answer me, Vida. Please answer me. What do you say? Please tell me. Please tell me. Yeah? So when you are doing it, beta, when you are doing it, remember you are taking the angle between A and B, even though you are subtracting, even though you are subtracting. Now, in the same way, if I want to find this alpha, if I want to find this alpha, okay, I want to find this alpha. So remember, this is going to be, so if I write this alpha, so I'll see, okay, I have some space here. So now remember this alpha is from here. So what is going to be tan alpha? So I am going to take it from where? From A. So how I am going to write it? See, leaving A alone and B sine theta. So what is the angle between A and B? Sir, it is 180 minus theta. Sine 180 minus theta is sine theta only. Sine theta only, isn't it? Just I don't have much space here, so I'm writing it directly. So do you agree? So when I write the angle between A and negative of B, it will be sine 180 minus theta. And sine 180 minus theta is nothing but the sine theta. Right? Now similarly, if I write A plus B cos theta, so it will become cos 180 minus theta, and cos 180 minus theta is minus cos theta. So can I write it A minus B cos theta? A minus B cos theta. Now, do you believe me that we have done nothing but the addition of vectors? So even when we say the vector subtraction, it is no subtraction, it is addition only. Do you agree or not? Please answer me. Please tell me, Vida. Do you agree or not? Right? Right? Please answer me. Do you agree or not? Please answer me, Vida. Right? Now let's try a few questions. Very simple question. Let's see if we can do it or not. Just a few questions we are going to see. Yeah, let's try this one. Very, very simple. Now I'll give you one shortcut again. I'll just give you one information. Now, if there are two equal vectors, let's suppose this is also a vector, this is also, so they are not equal vectors, they are equal in magnitude, because when we say equal vectors, so equal vector is also a type of vector. So two vectors are said to be equal vector when they are both equal in magnitude and direction, when they are having same magnitude and same direction. So these are not equal vectors, but these vectors are the ones which have same magnitude. Now, if this is theta, remember, if this is theta, and see, if the magnitude of two vectors is same, so the resultant is going to be exactly in the middle of these two vectors. Are you getting my point? Exactly, it is going to be in the middle of these two vectors. So if this is theta, this is going to be theta by 2, this is theta by 2. So these small hacks you need to remember, beta. Okay, and otherwise, what you are going to, you are not going to make any mistake, but you are going to apply the formula, you are going to waste some time. So, in order to save some time, we have to have this much, skills with us, right? This is small information is going to help you a lot. Now, please do it. Now, please do it. Well, you have given me some answer. The option seems incorrect, beta. See, what is you are going to do? So two vectors are there. The angle between two vectors is 60 degree. Okay, so let's apply the formula. So we have r is equal to root over a square, that is 10 square, plus 10 square, b square, that is 10 square, any hello beta, 2 10 10 and cos, what is the angle between two vectors? So it is 60 degree. It is 60 degrees. So can you write it as 10 root 3? Isn't it? Can we write it as 10 root 3? Fine, beta. Please answer me. Okay. See, how comes the cos 60 is 1 by 2? So 10 square plus 10 square plus 10 square, it is going to become 10 square 3, that is 10 root 3. And what is going to be? So see, simply this is 60 degrees. So the resultant is going to be bisecting this angle in the middle. So this is going to be 30 degrees. So what we can say, it is B option, right? Is it fine, my dear? Please tell me, what is the mistake that you have made? How root 3? I'll just tell you. So simply applying the formula. So R is equal to root over 10 square plus 10 square plus 2. This will be 10 square and cos 60 is 1 by 2. Okay, so this is going to be R is equal to root 10 square plus 10 square plus 10 square. Now can I also write it as root over 10 square into 3. So it is going to be 10 root 3. Isn't it? Isn't it? Hmm? Oh. So it is going to be 10 root 3 into 30 from the horizontal. I just made this B. Yeah. I just written B, but it was 30 degree. Yeah. Fine, beta? Fine. Now is it fine? Please answer me. A lot of questions are getting asked in this way. Okay. So see, for more questions, yeah, you have made a silly mistake. So for more questions like this, you can when you see all the vector chapters are there. So see, after if you watch this video, you'll get all the content. But for more questions, you have to go there. You forward the sessions and you get all the questions. Okay, wherever you see the question, stop the video, solve the question, see the solution. Right? Sounds good. So I'll just give so at the point when I was teaching this topic, I have given I think some more 2 3 questions that you can see in the session, right? Okay. Now moving forward. Now moving forward. Now let's have a few understandings. So if I say if I say theta is equal to 0 degree, if I say theta is equal to 0 degree, so angle between two vectors is 0. Okay, so if we connect them tail to tail, if we connect them tail to tail, so it will look like this. So if they will be lapped over each other, okay, then only the angle between them is 0. So this is also known as the parallel vector. When two vectors, when the angle between two vectors is 0, then this is what we call as the parallel vector. Okay, okay, okay. So if the angle between two vectors is 0, what is going to be r? Sir, it is going to be root over. See, we are going to use the formula, although it is very, very clear from here. Na? Two vectors in the same direction, so they will be obviously added. So it will be a square plus b square plus 2ab cos theta. So cos 0 is 1. So it will become a square plus b square plus 2ab. So r is going to become a plus b, isn't it? R is going to become a plus b whole of a square. So it is going to become a plus b. Okay. Okay. And this is going to be the maximum magnitude. This is going to be the maximum magnitude. How come, sir, it is going to be the maximum magnitude? Cos theta. What is the maximum value of cos theta? So it has to be 1. Now, according to the formula, simply that the resultant magnitude will be maximum when cos theta is maximum. Cos theta is maximum when it is 1. And when cos theta is maximum when it is 1. So when it is 1, that is theta is equal to 0. Understood, Beta? So this is the maximum magnitude two vectors can attain when they are added. Right? Wonderful. Now similarly, case 2. Now similarly, case 2. Okay. Now if I say case 2, so if let's suppose the angle between two vectors is 180. Now do you believe when the angle between two vectors 180 degree, let's apply the formula right away. So it is going to be 2ab cos 180, cos 180. Okay. So what is going to be the R? It is R A minus B. And I hope also you understand this, that no two vectors cannot have angle more than 180 degree between them. Right? How come, sir? Why not? See, if I say this is A, this is B, and let's suppose this angle is 210. What is going to be the angle between the vectors? Please answer me. What is going to be the angle between the vectors? Please answer me. What is going to be the angle between the vectors? If I represent two vectors like this, what is going to be the angle between the vectors? Any, if you want, you can also answer, my dear. Hmm? So, sir, obviously it is going to be 150, because we understand that when two vectors, whenever we are seeing the angle between two vectors, we need to have the minimum angle between two vectors. So this is going to be 150 degree. Understood, madam? This is going to be 150 degree. Okay. So now when I write theta is equal to 180, when I write theta is equal to 180, do you agree that this is going, because a square plus b square minus 2ab. So a square plus b square minus 2ab is a minus b whole of a square. It is going to be a minus b whole of a square. So when I write a minus b whole of a square, this is going to be a minus b, right? So this is going to be the minimum magnitude, isn't it? Minimum magnitude. Okay. Now this gives you a very, very important conclusion. What is the conclusion from this discussion we can draw? So if we write a vector plus b vector, okay, this is going to be the resultant. So the resultant magnitude, the magnitude of the resultant cannot be more than or less than the magnitude of A plus magnitude of B and magnitude of A minus magnitude of B, isn't it? Okay, and I shall write like this: difference. Okay, difference. Why? Because see, B can be greater than A also, na? Right? So don't take it like if A minus B is coming out to be minus one, so you take minus one. No, no, no. It is going to be plus one only because you are going to see the magnitude. Understood, beta? Now this is the reason why when I write 3 vector plus 4 vector, I write it could be anything between 7 and 1, right? In magnitude. In magnitude. Understood, beta? Now this is going to lead you to solve a lot of questions. A lot of questions. Like for example, if I say if let me give you one. Just a moment. So resultant A and B cannot be. I'll just more write some more options. Can you please answer this? What is going to be the answer? Thank you, Vida. What is going to be the answer? So very simply, because when we are adding resultant of A and B, and we just understand that subtraction is also addition only. So this is going to be in magnitude. It cannot be more than 7. It cannot be less than 1. So only 8 goes out of the range. So this is going to be the solution. Now let's come to the third case. Now let's come to the third case. Okay, third case. So let's suppose theta is equal to 90 degree. Very standard case. So theta is equal to 90 degrees, sir. So if two vectors are having their angle between them is 90 degrees, so this is going to be the resultant, no? Sir, cos 90 is 1. So right away you can write a square plus b square. Right away you can write a square plus b square. Is it fine, Beta? Please answer me. Is it fine? Do you agree or not? Okay. Okay. Now please understand this. Now please understand this. See, let's try to do one question here. Now if I say that two vectors are there, two vectors are there. This is a very standard question. Vector A is there, vector B is there. Now if they both are added, so they both are added, they are going to give you some magnitude. And if they both are subtracted, they are going to give you the same magnitude. Then the angle between, then the angle between A and B is. So I'll write 0 degree, 90 degree, 180 degree, and can't say. Can you give me the answer to this? B. So, A, you change your option. Your initial answer was correct only. Please understand this. Now, when I write the magnitude of vector A added to vector B, do you agree that this is going to be A square plus B square plus 2AB cos theta root over, okay, the angle between A and B. And if I write the magnitude of A minus B, very good, Anurag. If I write the magnitude of vector A minus B, this is going to be A square plus B square plus 2AB cos theta. 2AB cos theta, and it is going to be minus actually because we are subtracting now. We just developed the formula, and we also understood that when you are using this formula, we are having the angle between A and B, isn't it? Isn't it? Now from here, if we open up the bracket, we are getting 4AB cos theta. 4AB cos theta is equal to 0, isn't it? Please answer me. So from here, cos theta is equal to 0. So theta is equal to 90 degree, isn't it? So this is the way you can think of it conventionally. But just try to tell me one thing. See, see, whenever you are finding the resultant between, just try to think in this way. Whenever you are trying to find the resultant between any two vectors, if the vectors are going to be same, the theta term is not going to be there, isn't it? Isn't it? If two vectors are added or subtracted, okay, if two vectors are added or subtracted, the difference lies in the term that has the cos theta thing. Little confused? Okay, just listen this way, then I'll come back to this. Don't worry. So now if two vectors are added or subtracted, which term is different? Cos theta term is different. And if both are same, so if both are same, they can be only same if they comes out to be A square plus B square, isn't it? Isn't it? Right? And this only happens when theta is 90. Are you getting my point? Please answer me. Right? Okay. Now if this way you didn't get, don't worry. See, we understand. See, let me do it slowly. Now if two vectors are added, let's suppose they are going to get a resultant R, and if I write this magnitude, that is R. Okay, magnitude, let's suppose this is R. Now do you believe that this R is going to be A square plus B square plus 2AB cos theta? Do you agree to it, beta? अनुराग, बेटा देखो क्या है कि देखो, मुझे तो हिंदी में समझाने में कोई तकलीफ नहीं है, लेकिन आप इस बात को समझिए कि ये एक इंग्लिश चैनल है, ठीक है? अनअकैडमी का इंग्लिश चैनल है बेटा ये। तो इंग्लिश चैनल है तो यहाँ हिंदी बोलना, मतलब देखो हमारे ऊपर भी एक सरकार है ना? तो उन्होंने हिंदी बोलने से मतलब इसमें हिंदी में हम नहीं पढ़ा सकते हैं, ठीक है? आर यू गेटिंग माय पॉइंट? दैट इज व्हाई मैं यहाँ पे इंग्लिश बोल रहा हूँ, लेकिन आप कहते हैं तो मैं आपको समझाता हूँ, ठीक है? देखो बेटा, क्या चीज़ है, हम क्या करने की कोशिश कर रहे हैं, पहले ये समझते हैं। हम ये समझने की कोशिश कर रहे हैं वेक्टर के बारे में। तो वेक्टर के बारे में इस चैनल पे मैंने कंप्लीट सेशंस लिए हुए हैं, पूरा वेक्टर कंप्लीट किया हुआ है, लेकिन ये एक तरीके का ना रिवीजन सेशन है। तो अब आप मुझे बेटा ये बताइए कि आप लॉ ऑफ पैरेललोग्राम ऑफ वेक्टर समझते हैं? बताइए। तो जब आप लॉ ऑफ पैरेललोग्राम ऑफ वेक्टर देखते हो तो ये फॉर्मूला होता है ना, a प्लस बी वेक्टर इज इक्वल टू a स्क्वायर प्लस बी स्क्वायर 2ab cos थीटा एंड tan अल्फा इज b sin थीटा अपॉन a प्लस b cos थीटा। अनुराग, है ना? ये ठीक बात है, ये जानते हैं? बताइए। ठीक है, आई होप जानते हैं। अब अगर हम इन्हीं दो वेक्टर का सब्ट्रैक्शन करते हैं, तो सब्ट्रैक्शन कुछ नहीं होता, ये एडिशन ही होता है, एडिशन ही होता है। तो क्या किया आपने, ए वेक्टर माइनस बी वेक्टर किया तो ए प्लस माइनस बी लिख दिया, यानी आप रिजल्टेंट निकाल रहे हैं ए वेक्टर का और निगेटिव ऑफ बी वेक्टर का। तो आपने कुछ नहीं किया, आपने अपना फॉर्मूला लगा दिया। अच्छा, Yeah, this is an English channel. This is an English channel. I'll just give me a moment, Bala. I'll just reply to Anurag on this, and I'll then again start in English. Are you getting my point? ओके सो दिस इज एन इंग्लिश चैनल ओके हाँ अनुराग ठीक है मेरे भाई तो ये है ए ये है वेक्टर बी ये है ए ये है वेक्टर बी आपने क्या किया आपने इसका रिजल्टेंट निकाला तो जब आपने इसका रिजल्टेंट निकाला तो इन दोनों वेक्टर के बीच का एंगल क्या था 180 माइनस थीटा तो क्या फॉर्मूला बन गया आर डैश इज इक्वल टू ए स्क्वायर प्लस बी स्क्वायर माइनस 2ab cos थीटा तो ये आप ऐसा फॉर्मूला की तरह समझते हो सब्ट्रैक्शन ऑफ वेक्टर को गेटिंग माय पॉइंट ओके बट ये सब्ट्रैक्शन ही एडिशन ही होता है और यहाँ ध्यान देने की बात क्या है कि जो थीटा होता है इट इज द एंगल बिटवीन ए एंड बी वेक्टर अंडरस्टूड बेटा अब देखो यहाँ क्या कह रहा है नाउ लेट मी एक्सप्लेन ठीक है अभी when we have a vector plus b vector the resultant is going to be given by this formula from law of parallelogram of forces अनुराग देखो a वेक्टर b वेक्टर किया तो इसका रिजल्टेंट क्या आता है इस फॉर्मूले से आता है आर यू गेटिंग माय पॉइंट नाउ सिंपली अगर मैंने किया इफ आई डू बला प्लीज लिसन टू मी नाउ so now see a vector plus b vector the magnitude of the resultant is going to be given by the law of parallelogram of vectors so it will be this now if I subtract these two vectors okay their resultant let's suppose this r dash okay r dash and this I can write it as r dash only so this r dash is given by the formula I am just applying the formula so you understand when two vectors are subtracted it is going to give you the result like this minus 2ab cos theta now it is said in the question that magnitude of a plus b and magnitude of a minus b is same. So I am going to write whatever is given in the question. So can I equate r and r dash? Can I equate r and r dash? Please answer me. बोले just a minute. So actually my phone call came and your chat is stopped in my mobile. Yeah. Okay, so r is going to be equal to r dash. So I'm just going to write simple mathematically. We are going to write them here. So if I write them here, see simply it is going to be root over a square plus b square plus 2ab cos theta and it is going to be equal to root over yeah I teach there also in special classes you can find me by my name Umashankar Tripathi okay so there also I take classes in the special okay okay now proceeding from here okay now if I square both sides so it will become a square plus b square plus 2ab cos theta is equal to a square plus b square minus 2ab cos theta okay okay 2ab cos theta is equal to 0 so the cos theta will become how much ये हो गया 0 because 4ab can't be 0 so cos theta is going to be 0 so theta is going to become 90 degree ठीक है अनुराग देखो कुछ नहीं किया भैया ये दोनों को उठा के इक्वेट कर दिया ये क्वेश्चन नहीं कहा है तो दोनों को इक्वेट कर दिया दोनों तरफ स्क्वायर कर दिया ओके तो क्या आ गया थीटा हो गया 90 अंडरस्टूड बेटा right I hope it is fine to you now let's move to a very interesting question let's see how you approach it okay I'll give you some time see and again I am telling you this see I'm not giving each and every question, otherwise it will be a normal session. Na? So if I want to complete the vector, I'll have to skip some important questions. But if you want to do those questions, please watch the sessions on vector. Okay. So when you watch the session, I'll complete all the concepts I have said. But for more questions, you have to go back to the channel. You have to see the sessions on vectors, and only thing that you must do, you may forward the video, you may go to the question right away, you can start attempting them. Okay? Now let's try this question. Let's see if we can do it. And I want to see, not only I want to see that you are going to get the right answer, but I want to see your approach of solving this question. Ah, let's proceed. Correct. Let's see if we can do it or not. Very interesting question. Let's see how you guys are going to approach this question. Please give me the answer. Hmm. Wrong answer, अनुराग. करो ना, थोड़ा कोशिश करना यार. हो जाएगा भाई. Let's try again, अनुराग. No worries. See, with these kind of a question, you'll get concept clarity in your mind. Then you can do multiple questions, right? Please try it. And I believe if you guys would have been using the right approach, the solution must have been done by now. See, if you want to crack the NEET examination, I have an advice for you. See, not only you must understand the topics, you must try to figure out if there is any, better way of solving the question, because you need to save some time also, right? In competition, knowledge and efficiency, okay, both are very important. Bala, what is your answer? Should I do it? What is the answer to this question? Anurag. Wrong answer. This way you are going to answer all the options. Bala, your answer is correct. Okay, I'll do it now. Now, see, if you have done it correctly, also, if you have not done it correctly, also, I want your 100% attention towards this. The sum of the magnitude of two forces acting at a point is 18. Now, how a student is going to attempt it? Now, see, I'll tell you how we normally attempt it. So, two vectors are there, their magnitude, sum of the two forces, magnitude, and when we write just A and B, we do not write like this. So, just we are talking about the magnitude. Now, A plus B is 18. The magnitude of their resultant is 12. That is, A vector plus B vector will have a resultant R vector. So R is going to be 12. Okay. So now it is said that if the resultant is 90 degree with the force of a smaller magnitude. Now how students will be doing it? So first of all, they say that let's suppose A is the smaller. Yeah. Bala, just wait, just wait. I'll show you. I'll show you that how we can be with using a brain for 10 seconds. We can save at least 3 minutes in a question. I'll just show you this. So now student would do it like this. So this is going to be A. This resultant is 90 degree. So one thing is very clear that B will be somewhere here, no? Because this R is going to be the diagonal of the parallelogram. Okay, so B will be somewhere here. Now how they are going to attempt it? So see, they are going to do it like this. So now R we understand is equal to root over A square plus B square plus 2AB cos theta. 2AB cos theta, right? Now R is given to us, sir, it is magnitude 12. Sir, we can have it as 12 square is equal to A square plus B square plus 2AB cos theta. Sir, we have three variables here, sir. We have three variables here. So we cannot do it this way. Okay, there is some problem is there. Now for proceeding from here, I need the theta. So sir, they use this information. Sir, alpha is given as 90 degree. Alpha is given as 90 degrees. So sir, we know tan alpha is b sine theta upon a plus b sine theta. We are good at memorizing the formulas, na? Because see, don't mind me saying this, because I have seen the students who are preparing for the NEET examination because they do biology this way only, na? They do rectification in everything. Okay, so then this things happen. Now I am doing the rectification way. Please understand. The rectification, that means memorization. Okay, so you have a very good memory to memorize the formula, na? So formula came up like out of nowhere in every question. So this is going to be tan alpha as a tan 90 degree. This is going to be b sine theta. B sine theta. Oh, sorry. This was a plus cos theta, na? B cos theta. So a plus b cos theta. A plus b cos theta. So tan 90 is going to be 1 by 0. So from here, we are going to write a plus, yeah. Sorry, I just made the correction. This is cos theta. So a plus b cos theta is going to be 0, sir. A plus B cos theta is going to be 0, sir. So from here we can write B cos theta is equal to minus of A. Minus of A. Okay. B cos theta is going to be minus of A. Right? Do you agree to it? Yes, sir. Now what we can do, sir? We can put this back here. We can put this back here. So this is going to be 12 square is equal to A square plus B square, and this is going to be minus of 2A square. This is going to be minus of 2A square. So this will become B square minus A square 144. And what is given? Sir, A plus B is equal to 18. A plus B is equal to 18. Now we have two equation, two variable. So we can solve them further and we can find A and B. Right? Right? So I'll just take a moment here. I'll just stop here. Okay. Now first tell me, all of you who have attempted this question, have you attempted this way or not? Please answer me. Have you attempted this way or not? Just give me yes or no. Have you attempted this way or not? Please answer me. Please answer me. Yes or no? Have we attempted this question this way? Yes, sir, we have attempted this way. Now I tell you one thing. So you forget what I said. I told you one thing. Whenever Anurag. So which way you have attempted, beta? If not this way, can you tell me? If not this way, you have attempted, because I have seen students normally attempt this way. So which way you have attempted? Can you give me that? Which way you have attempted, my dear? Can you tell me which way you have attempted? कैसे attempt किया? चलो, no worry. I'll just tell you one way. Now please listen to me. Now normally I have seen students are attempting. So this is mathematically only, na? You are saying, sir, mathematically. So this is also mathematically, na? Isn't it? Yes, sir. So normally, but normally students attempt this way. Okay. Bala have attempted this way. I have seen most of the students are attempting this question this way only. Now I am going to do it again. So why you are going to do it again? Just I want to tell you something. Okay. So the sum of the magnitude of two forces acting at a point is 18 and magnitude of their resultant is 12. Okay. So you forget me when I said that whenever you see 90-degree, you can use the triangle law. See, this is how you can save some time. Now let's do it. So it says there are two vectors. So let's suppose one vector is A, one vector is A. Now the resultant of this vector is making an angle of 90-degree with force of smaller. So this is going to be your Arna at 90-degree. This is going to be your Arna at 90-degree. Now please understand this. If this is the resultant, do we have any option other than being this? Please answer me. Because law of triangular forces says that when two vectors are added, two vectors are given by two sides of the triangle taken in the same order, the resultant is going to be the vector given by the third side of the triangle taken in opposite order. So that is going to be this R vector, isn't it? Do you agree or not? Please answer me. Please answer me. So this is going to be A vector and this is your R vector. So this has to be the B vector, isn't it? The triangle is drawn now. Now from here right away, can't you say R square is equal to A square plus B square, right? Now when R square is equal to A square plus B square, this is going to be 144. This is going to be how much? This is going to be one, or sorry. This way we can't do that. So see, here, this is going to be A, B, and R. This is going to be A, B, and R. So see, from here, so B is the hypotenuse, na? B is the hypotenuse. So B square is equal to R square plus A square, isn't it? Right away. Do you agree or not? Are here B is the hypotenuse, na? I was doing R square is equal to A square plus B square. B is the hypotenuse. So B is the hypotenuse. So B is the hypotenuse. So B square is equal to R square plus A square. So R square is equal to B square minus A square. So this is going to be 144 is equal to B square minus A square, and B plus A is given to be 18. Now please try to understand this. Now you reach to this by doing all this thing. No, using this much formula, this much calculation. But if you give 10 seconds and think that which approach I shall follow, you reach here directly, isn't it? Please answer me. Please answer me. Yes or no? Bala and Anurag. Did you get this point or not? Did you get this point or not? Please answer me. The question becomes simpler, taking less time, isn't it? Now let's try one more. Now from here, can we solve further? Yes, sir, obviously we can solve further. So 144 b square minus a square will become b minus a, b plus a, okay? And a plus b is given as 18. So I can write b minus a is equal to 18 by 144. So 18 by 144 will become 18, no? Sorry, 8. Okay, will become 8, isn't it? Yeah, it will become 8, right? Okay, so b minus a will become 8, b plus a is going to be 18. It is given in the question. It is given in the question. So from here, what we can say, so 2b is equal to 26, so b is 13. Okay, if b is 13, a is going to be how much? It is going to be 5, right? So what is going to be the answer to this? C option. Clear? Now let's try one more. Just a moment. I'll just give you one more question. See, understanding the right approach to attempt a question is very, very important. It will save your time, it will save your energy in the examination. Okay, now let's try this one. Let's see if we can do it. I'll give you some options. No, I want you to do this with the right approach, and I want you to give the answer very, very quickly. Please go for it, beta. Please be careful while you are answering this. Please answer it. Let's see if we can do it or not. See, I want you to use the right approach. Let's see. Any answers? Any answers, guys? Oh, and for new students, please don't forget to subscribe the channel also, na? This is going to help us. If possible, please share to your friends also so that they can also subscribe. So Anurag have given some answer. Uh, Anurag, your answer is not correct, my dear. Not correct. Please try again. No worry. No worry. See, if it is going to take some more time, that is also okay. But the thing is that if you are learning something, you must understand it completely. Anurag, there is only one solution to that you practice more and try to be patient. From my experience, I can tell you that I too make mistakes mathematically. Lastly, I have written sine theta, cos theta. This happens to everyone. See, whoever is studying seriously will definitely make the silly mistakes. Okay. Only the thing is, you must try to control it. You cannot avoid it completely, right? So, how to control it? With practice. That's all. Okay. More often you make this mistake, more unlikely you are going to make सेम मिस्टेक अगेन. समझ रहे हो? मतलब अपनी गलती जो होती है, अगर आप एग्जाम से पहले गलतियां ज्यादा कर रहे हो तो ये अच्छी बात है ना. जितनी गलतियां पहले करोगे एग्जाम के उतनी ही गलती कम होने के चांसेस रहते हैं. ठीक है, तो उसके लिए क्या करना है? प्रैक्टिस ज्यादा करिए. प्रैक्टिस ज्यादा करेंगे गलती ज्यादा करेंगे. गलती ज्यादा करेंगे तो आगे चल के गलती होने की संभावना कम होगी. सो इसके लिए परेशान मत होइए. देयर इज नथिंग टू वरी अबाउट दिस. राइट, दिस इज अ नेचुरल थिंग. इट हैपेंस विद एवरीवन. हाँ भला. What is your answer to this, बेटा? अनुराग, यू ट्राई अगेन. कोशिश करो भाई, कुछ भी नहीं है. वेक्टर पूरी फिजिक्स में लगेगा, समझो बात को. ठीक है, आई टेल यू दिस वेरी सीरियसली. वेक्टर इज गोइंग टू बी यूज इन होल ऑफ द फिजिक्स. इफ यू हैव कंफ्यूजन इन वेक्टर, you will always have some pain in physics, no matter what. Right, you will never be comfortable in the physics. Very good, Bala. Okay, so now I'll check. Try. So now you can do this question graphically, you can do this question analytically, you can do this question graphically through triangle, you can do this question graphically through parallelogram. Any way you want, you can do this question. Now let's try. So the resultant of two vector A and B is perpendicular to vector A. Let's make vector A. Okay. The resultant of it is going to be perpendicular to vector A. Okay. And its magnitude is half the magnitude of vector B. Now, if this is A, this is R, this has to be B, right? This has to be vector B. And this angle is 90 degree, and it says that magnitude is half of magnitude of B. So this is going to be B by 2. Now, if I consider this angle to be X, time consuming, how come it is? You again use the analytical approach. Have you not used this approach, Bella? I'll just explain again. See, my dear. See, first of all, I'll tell you one this. Whenever you see 90 degree in a question, always do graphically. That's all. Take this tip in your mind. Whenever you see 90 degree in a question of vector or related to vector, whether it is force, whether it is velocity, whether it is acceleration, whether it is anything, displacement, whether it is anything, whenever the 90 degrees there, it is always advisable that you go graphical. Don't worry. Right? Now, calculation. Okay, again you go by the calculation. No worries. Choice is yours ultimately. So we have the A vector. That way, obviously, it is going to take more time. Now you are going to do the root and you are going to write that big formula. Definitely, it is going to take time, right? This way, see, vector A resultant R is perpendicular. So it will take some time to change the ways, right? Don't worry about it. So R vector is going to be 90 degree to the A vector. R vector is going to be 90 degree, resultant is going to be 90 degree of A. So this has to be B from the law of triangle, right? Okay. Okay, this has to be B. Now the magnitude of this R is said to be half the magnitude of B. So if it is half the magnitude of B, this is going to be B by 2. This is going to be B by 2. So let's suppose this angle is X. This angle is X. Now this angle is X. So can we write sine X is equal to the perpendicular upon hypotenuse. So R upon B. So this is going to be B by 2 upon B. So X is going to be how much, sir? This is going to be 30 degree. This is going to be 30 degree. So what is going to be the right option? Please answer me. Anurag. क्या होगा भैया 30 डिग्री आ गया क्या है आंसर प्लीज आंसर मी एंड यू ऑल्सो बाला व्हाट इज गोइंग टू बी द आंसर हाउ मच कैलकुलेशन इट रिक्वायर just one line in one line it is solved. What is going to be the option? Please answer me. A, B. What is going to be the option? Please answer me. Hello, Arshad Ali. अरे बोलो ना भाई क्या आंसर होगा व्हाट इज गोइंग टू बी द आंसर अरे सब तो निकाल दिया आप तो बता दो व्हाट अबाउट यू अनुराग व्हाट इज योर आंसर इन दिस So now here many students make one mistake. So they forget the angle between the vectors. They forget the angle between the vectors, right? So how they forget the angle between the vectors? So sir, they forget that the angle between the vectors is when they are connected tail to tail. Anurag, do you get this point? So this is not the angle between the vector. This has to be the angle between the vector. Na? So this is going to be 180 minus x, that is minus 30. So this is going to be 150. Understood? Now, sir, let's solve this with parallelogram without using the formula. So this is vector A now. This is vector A. Now, please tell me, it is given in the question. Now you only learn to solve conceptually, right? Okay, so this is what happens. See, please understand this. There's nothing wrong about it. Many times, even we as a teacher also see the right concept comes in your mind. That is, that is my voice is not clear. Is there any disturbance in my voice? Can you guys please confirm me? Ashok is telling me that my voice has some disturbance. From my end, it seems to be fine only. Hmm? Is there any disturbance in my voice? Can you guys hear me properly? Okay, this is fine only. Ashok, there might be some connection issues at your end. Okay, so let's continue. So now let's try to solve it with parallelogram. So see one more concept. One more concept. So A vector is there. Now it is said that the resultant is 90 degree from A vector. So this is going to be 90 degree from A vector. Okay. Now if I use the law of parallelogram, so see this is going to be the diagonal now. So the if I am completing the parallelogram. So if I complete the parallelogram, this is going to be your B vector, isn't it? This is going to be your B vector, is it or isn't it? Please answer me. Yeah, yeah. Okay. Now please understand this. If this is 90, this is right away 60, isn't it? Okay. Sir, how you can say that? How you can say that? Now, do you believe it or not? Hmm? Do you believe it or not? Sir, how come, sir? When R is B by 2, see, this is given to be B by 2. See, this R is B by 2. This is 90, so this is 90. This is B. So base is now B by 2 and hypotenuse is B. So it has to be 60 now. So right away from here you get 150. So no way you do. No way you do. No way you do. There is no need of going through for the formulas. Any way you do. The graphical method is very, very helpful at times. Are you getting my point? This is going to save a lot of time of yours. Right? Okay. Now let's move forward. So I hope this concept is clear. So see, there are further more questions on it. You can watch the regular session on this channel. So there will be more questions. So those who are watching this session, all the concept I am covering here, but for question purposes, beta, see, you may see the session. Okay, you may see the sessions, and you can take up some questions from there. Now let's do one more question, which helps you understand the concept of the subtraction. Ah, let's try it. I'll just give you some options. Mm. Yes, we can do that, Bala. But the thing is, see, as I say, see, I don't have the habit to make like the promises like that. So, see, you understand that I am working in an organization. Arshad, how it concerns your preparation? Though just to answer you, yes, I am. Okay. but I don't think it is going to help you, and this information is going to be asked in the NEET 2024. I highly doubt it. So Bala, I was saying, see, we are working in an organization, so there are some guidelines that are provided to us from the, from the concerned authorities. So now, as per their guidelines, they ask me to proceed in a manner shall I don't jump any topic. So, like, as per the instruction I'm having right now, okay, I can't jump the topics. Although, as you are, because see, this optics, I think you are the second students who have asked me to do so. So I'll raise the request if it is possible. See, I don't mind. Okay, but right now the instructions I am having, the guidelines I am having is to move in a systematic manner. So, like we are about to complete, the kinematics motion in 1D, 2D. Okay, this vector is a part of motion in a plane. You understand, like as per the NCRT syllabus and NEET syllabus, right? Okay. Now let's try this question. So we'll see too. Don't worry. Okay, we'll try. What is going to be the answer to it? See, just take some time, beta. Before you answer, just take some time. Don't worry about it. Read the question. See, physics is all about this only. You skip a small point, you are going to lead to the wrong answer. And normally, see, in the examinations like NEET or like such a standard examination, what happens? You are going to have one option ready for you for each of your silly mistakes. These options are not random options. These are well calculated options, and you make one mistake, you end up, you know, giving the wrong answer and attract the negative marking. So please think before you answer. Arshad, you can also try answering this, and Anurag, the live student. Let's try this one. Please take some time. Bala, is it your final answer? Is this your final answer? Your final answer. That is the wrong answer. I'll do it now. Please observe. So it says a particle is moving with a velocity of 5 meter per second towards east, and its velocity changes to 5 meter per second not in 10 seconds. Find the acceleration. Now I hope we understand that acceleration is given by change in velocity, that is final velocity minus initial velocity upon change in time. Do we have any confusion in this? Do we believe this? Yes or no? Acceleration is given by change in velocity upon change in time. That means the final velocity minus initial velocity upon change in time. So it says the particle is moving with velocity 5 meter per second towards the east. So it is moving like this 5 meter per second. Okay. This is your initial velocity vector. This is your initial velocity vector. Okay. Now this has changed 5 meter per second north. So this is your final velocity vector. This is your final velocity vector, isn't it? Isn't it? Now, when you have answered, now when I, it seems to me that when you have answered this question, Bala, you did V2 vector plus V1 vector. You forgot about the subtraction I told you, isn't it? Right? Now, please understand this. In this, we do not have to calculate V2 vector. This is where, see, you have to apply those concepts that you have learned. See, we need to do V2 vector minus V1 vector. That means we need to do V2 vector plus minus of V1 vector, isn't it, beta? Are you getting this point? So basically, you have to reverse this. So you can now use triangle, you can use parallelogram, whichever you want. But you want to do it like this. So this is, if I reverse this direction, can I make this vector like this? Please answer me. So this is 5 in magnitude, right? So this is going to be this vector. Did you get this? So what is going to be the resultant? So if we use the triangle, so this is going to be the resultant now, beta. This is going to be the resultant. This is minus V1. This is plus V2, isn't it? So this is going to be the resultant. So what is this direction, sir? This is going to be northwest direction. So it is not northeast. It is going to be northwest. And now see, this is 5. This is 5. So this is obviously 5 root 2. And a standard triangle, right? Pythagoras, isn't it? So this is going to be 5 root 2. So it is going to be 5 root 2. So V2 minus V1, this is 5 root 2 upon time is 10. So it is 2 by root 2 by 2 magnitude. So it is going to be 1 by root 2. And what is the direction? This is northwest, no? This is northwest, no? So this is going to be B option. Understood, Peter? Right? Please answer me. Did you get this or not? Sir, we want to do by parallelogram. Okay, do by parallelogram. So this is your, whichever comes in your mind. See, whenever this is 90 degree, no need to use that big formulas. 5 meter per second. This is your V1 vector. I'll do it in the next page. So we want to do, yeah, you forgot about the direction. Okay, so if you forget, then that is why I said that. So normally, see, this kind of a question, subtraction is very important because so this is V2, right? This is V2. Now I want to do the reverse. So firstly, I have to reverse this direction. So if I reverse this, this go by like this. This is your negative of V1. Na? This is negative of V1, that is 5 meter per second. This is going to be your V2. So this is going to be, so now these are connected tail to tail, right? Now when they are connected tail to tail, you are going to have the resultant like this, isn't it? This again northwest, and this is going to be, so when the angle between two is 90 degree, you can do right away whatever comes in your mind first. This is under root of 5 square plus 5 square. By the formula also, it is going to be 5 root 2. Is it clear, beta? Now I request you to do one thing. Please go to the session of vectors. I think it would be by the name of vector subtraction or addition. You will find I have, after this question, we have solved some more questions. Please go and solve them after this session. Okay. Okay. Now one big part of vectors completed, that is addition, subtraction, and basic understanding of vector. Now the second part and very important part is the resolution. Okay. These are interrelated topics. Vector in Cartesian, vector in Cartesian coordinates, okay, and position and displacement vector. This is the second zone of the vector understanding. Now, shall I move to this? Right? No, not yet. So, basically, when more people will start coming to the channel, we'll make a Telegram channel. Okay, beta? But if you, you can Watch my sessions on Unacademy also, on the app. Okay? Okay. You need these notes? Okay. So I'll do one thing. See, there is no upper age limit to the NEET examination. So it depends upon like what is there's no suitable age to do something, right? This is what I believe. Like, but to secure your career, you must not prepare for any examination more than 2 to 3 years. This is personal, what I believe. Huh. So, Bala, I'll think of it that how we can. I may make a Google Drive and I'll make a comment. The first comment I'll myself will make on this video when this video ends, and I'll put a Google Drive. Okay, the notes will be there. Okay, and I may also. So, do you want me to combine all the sessions previously I have taken and make a note of it, and that also I want to you want me to put? Hmm? So we'll see to it. In the end, we'll talk about it. Okay, so this is basically the second part of the vector that is very, very important. So resolution vector in Cartesian, position and displacement vector. Very important, very useful. So very simple also. Now please observe. Let's do it. Okay, now please observe. Let's suppose we are having a vector A. Let's suppose we are having, acha, one more thing. So, like with this discussion now of velocity and vector subtraction, I also taught uniform circular motion using this concept. Okay, so please watch that also. है ना? In the session itself of the, I think, subtraction, I taught after the subtraction, I use this concept to explain the uniform circular motion. So you can watch that also, right? Okay. Now please understand this. Let's move further. Okay, so see, very, very simple, very, very simple. So I'll just going to combine all these things and going to tell you briefly. So if there is a vector A vector, if there is a vector A vector, so we know that we are having these axes. We are having this axis like this. Okay, please understand this. Now, if this angle is theta, this angle is theta. Okay, so we can have the component of it in this direction. See, so if you want to have the component, if you want to have the component of a vector, if you want to have a component of a vector in any direction, so you just have to see that what is the angle it is making with that direction. Okay, not, but I'll leave it. You don't get into this. This see, this happens, right? You have so see you see this kind of a thing happens, so you don't mind all this, right? So now this is a vector, this is a vector, this is theta. Okay, so this is a cos theta and this is going to be a sin theta. Okay, this is going to be a sin theta. Understood, beta? This is going to be a sin theta. Okay, so simply see, just remember one thing. Now, don't remember this way that horizontal axis it is cos theta, vertical axis it is sin theta. Many students do this mistake. It is not like that. It is not like that at all. See, with the axis, if the angle of a vector from an axis is theta, to that axis it will be cos theta, and perpendicular to that axis it is going to be sin theta. Are you getting my point, beta? Are you getting my point? Okay. Okay. Now, simply if I say like this, please observe. Let's suppose we are having a vector B and it makes an angle, let's say theta here. Now what is going to be the component of this vector in x and y direction, a standard x and y direction? So sir, see, it makes theta here. So what we got to do, sir? What we got to do? We got to do it like this. So this will become b cos theta and this is going to become b sine theta. Okay. B sine theta. Are you getting my point, beta? Are you getting my point? Okay. So see, whichever axis, so you have a vector. If it is making the angle from some axis, you go cos theta if you want to have a component of it in that axis. Okay. And yeah, and perpendicular to that axis, you can go by sine theta because see, it is nothing but so you can write it as a 90 minus theta. Now cos 90 minus theta is going to be sine theta only, right? I hope this is fine to you. Now please understand this. Let's suppose we are having a vector. We are having a vector like this. Okay. We are having a vector like this. And I want to have, so let's do it with the help of some question, one question. Okay. So this thing is clear now. Now please understand this. So let's suppose we are having something like this, an inclined plane. Just trying to understand the resolution. Then I'll take this to the use of the Cartesian. From here will evolve into the Cartesian. This is here a body having a weight W. Now let's suppose this is angle theta. Now please remember you can take the resolution of a vector in any two perpendicular axes. Okay, not axes but axes. The plural of axis is axes, right? So if there is a vector like force, velocity, acceleration, or any vector, you can have the component of that vector in any two mutual perpendicular direction. Not necessarily it has to be in x and y direction. Are you getting my point? Okay. Okay. Now, can you tell me that what is going to be the force? Force is a vector, right? What is going to be the force? Let's suppose this is your n direction, okay, and perpendicular to n, this is your m direction. Understood? Can you get me the component of weight of this body in m and n direction? Can you try to do that? Again, Bala, see, these things now you have to do nothing about it. First, my advice is okay, sir, you are weak in geometrical angle concepts. See, in physics, when you read now, you'll have to use so much of geometry now that with time you will be able to understand. Like, for example, sir, I don't know the formula of cos 2 theta. It's okay right now. Well, see, with the journey of physics, wherever you find, okay, here I have to use the cos 2 theta. Now, understanding the concept and the use of that angle, you will understand the geometry also. Understood, beta? Okay. So, see, you go again, this is my advice, right? My advice that you move forward in the physics. Let it be as it is right now. You try to learn the tools of mathematics wherever it is getting used in your physics. Like, for example, on this channel, I have made a video on differentiation and integration. Now, only that is required for you to use in kinematics. Are you getting my point? Okay. So, this way we can proceed. This is my advice because there's no time. Don't have this much time that we first understand. We go back to the 10th. We go back to the basic geometry. Start learning the basic trigonometry. Don't do that. Okay. Now please answer me. What is going to be the component of the weight of this body along n and m direction? Very very useful. Very standard case of inclined plane. Please try to do that. I'm very sure we can do. Let's try. See, you can have the component of any vector in any two mutual perpendicular direction, no matter that they are x and y. Normally, students think that we do the resolution in x and y only. It is nothing like that. Any answer? Any answer, my dear? So see how we are going to do it. Now please observe. So now weight always acts vertically downwards. Okay. There's no confusion in that. So this is going to be the direction of weight, right? This is going to be the direction of weight. Now if it is the direction of weight, beta, this is theta. Now if this is theta, this is 90, this is 90. So this is going to be theta. How comes, sir? See, please observe. Now, see, I'll just extend this. Now, if this is theta, this is also theta. Now, if this is theta, this is also theta. This is 90. So this is 90 minus theta, right? Okay, this is 90 minus theta. So this is going to be how much, sir? This is going to be your theta. Do you agree to it or not? Please answer me. Right? Yes, sir. Absolutely. This is going to be theta. Now, this is going to be theta. So, what is the component of a vector when it makes an angle of theta with an axis? So, this is going to be w cos theta, and this is going to be w sine theta. So, this is how we can get the resolution of a vector along any two perpendicular axes. Yes or no? Please answer me. Please tell me, Vida. Is it fine or not? Okay, let's try one more. Just to get an idea of the resolution, because this is going to be very, very useful lately also in courses and everything. Okay, let's try it. Yeah, any answer to this? So what does this question says? It says a man rows a boat with a speed of 18 km per hour in northwest direction. The shoreline makes an angle of 15 degrees south of west. Very well. Obtain the component of the velocity of the boat along the shoreline and perpendicular to the shoreline. Okay, now what does this question say? So it says a man rows a boat with a speed of 18 kilometer per hour, 18 kilometer per hour in northwest direction. So it is going in 18 kilometer per hour in northwest direction, 18 kilometer per hour in northwest direction. The shoreline makes an angle of 15 degree south of west. So south of west, that means, so this is obviously east, west, north and south. So 15 degrees south of west, that means this angle, isn't it? That means this angle, right? Okay, so this is going to be 18. So if this is 15, so if I draw a 90 degree from here, so if I draw a 90 degrees, so this is 45 obviously. This is 45. Why, sir? It is north of west now. It is northwest. So northwest, that is 45. Now if I make an angle of 90 degree from this, so this, let's suppose this is x, what we call it. Let's suppose this is PP axis and this is QQ axis, whatever you can call it. Now you need to have, you need to have a component of it. You need to have a component of it in the direction of the shoreline and perpendicular to the shoreline. So what it is going to be, sir? So now this is 60 degrees. So obviously, sir, this is going to be 18 cos 60. Okay, this is going to be 18 cos 60. And now what is going to be perpendicular to this? This is going to be 18 sin 60, isn't it? Very, very simple, sir. 18 sin 60, right? Now, whatever we get, okay? Now, this is how we can take the resolution. This is how we can take the resolution of any vector, okay, in any two given mutual perpendicular axes, right? I hope this is fine to you. So I hope resolution is sorted. I hope your resolution is sorted. Now moving further from this point, I want you to understand one more type of vector, that is the unit vector. So the live student, if you can tell me that everything is clear up to this point, okay, we are going to move into the Cartesian thing. So for that, I want you to, understand the unit vector first, right? Now, can we say up to this point everything is clear? Yeah. Can we say so? Can we say up to this point everything is clear? Yeah. I hope yeah. Now, what is the unit vector? See, very important and very useful in physics. So, see, unit vector, as the name suggests, this is a vector which has magnitude of unity. What is the magnitude of unit vector, beta? So the magnitude of the unit vector is unity. That means it is basically 1. Okay, it is basically 1. So now what is the purpose of the unit vector? What is the purpose of the unit vector in physics? So the unit vector has a purpose. The unit vector has a purpose to give direction. Okay, so in physics this unit vector has only one role. What is that role, sir? The role of a unit vector in physics is to give direction, is to give the direction of any vector. Okay, okay, so very important thing, very important thing. Now let's suppose, please understand this. Let's suppose we are having the a vector. We are having a vector a. Okay, we are having the vector a. Now please understand this. This vector will have some magnitude. Okay, let's suppose the magnitude of this vector is a mod, and definitely it is going to have some direction. Now, who is going to give the direction of this vector? Sir, unit vector in the direction of a. So when you have the unit vector, so it is so important in physics that a different notation is given to the unit vector. So it is represented as a cap. Okay. Okay. So if there is a vector A, please understand this. If there is a vector A, it will have some magnitude. It will have some magnitude. But if you want to represent the direction of A, so what you can use? You can use the unit vector in the direction of A. That is A cap. So what is the relevance of this unit vector? So see, what is this A cap basically? So if you take, if you take only one unit magnitude along this direction, that is going to be represented by a cap. So this a cap or the unit vector has only one purpose to serve in physics, that it shows the direction. Okay, so mathematically what is going to be the a cap? See, this is going to be highly useful, and in Cartesian basically this is going to play a very important role, or I can say the most important role. Now from here, can we write that a cap, that is unit vector in a direction, is going to be a vector upon mod of a, is going to be a vector upon mod of a. Okay, okay, let's keep it with us, right? We'll be using this a lot. Okay, now please understand this. Now this is the unit vector. Now one type of unit vector is what we call as the orthogonal unit vector. Orthogonal unit vector. Now what is the relevance of this orthogonal unit vector? Please understand this. So see what are the directions we are having? Sir, we are having x direction. We are having So we are having x direction, we are having y direction, we are having z direction. So we understand these directions now. We understand the direction of x, y, and z. So if I show this direction through the thumb of mine, so this is your x direction, this is y, and this is generally what we call as the z, right? Positive x, positive y, and positive z. So in three-dimensional thing, whenever we are talking in three dimension, basically we talk in three directions, that is x direction, that is y direction, that is z direction. Now what is the purpose of orthogonal unit vector? So at the end of the day, this is a vector. So what is the purpose of unit vector? Orthogonal unit vector is also a vector, na? So what is the purpose of this orthogonal unit vector? So basically, since it is a unit vector, so it has a purpose of showing that direction or representing that direction. So since x, y, and z are the most used direction, and any direction or any position, any vector can be represented obviously in the form of x, y, z. So that is the reason why we are going to introduce the unit vector in these three orthogonal direction. In general, orthogonal means perpendicular. So we have x, y, and z. So when we are having this x, y, and z, let's introduce a vector in unit vector in x direction. So we call it I cap. In y direction, this is going to be j cap, and in k direction, it is going to be k cap. It is going to be k cap. So we have I cap, j cap, and K cap. Is it fine, Buddha? Please answer me. Yes, sir, this is fine only. So basically, what is this I cap? What is this J cap? What is this K cap? So this is going to be the unit vector in X, Y, and Z direction respectively. Right? Right. Now please understand this. What is the use of it? Now, if I say that a boy walks in or a boy walks 3 meter east. Okay. Now, if you want to represent it in terms of a vector in orthogonal, using orthogonal unit vector, so how you are going to represent this displacement? So let's suppose, hello Shivesh, hello Kumar. So we are dealing in this session. I'm going to, give you a complete revision in this vector. So till now we have done with the addition subtraction. Now we just entered into the resolution. So in the second zone of the vector, that is going to be the resolution and the unit vector thing. Okay. So in this section, I'll be completing the whole vector. Okay, on a revision basis. Okay. So when I say a boy walks 3 meter east, so when a boy walks 3 meter east, so basically we know this is east, west, north, and south. So from some point, if someone walks 3 meter east, how you are going to represent it using a vector and unit vector? So you can write 3 of I cap. Are you getting my point? So now when I say 3 of I cap, let's suppose X vector is 3 of I cap. So right away you get an understanding that this is a vector of magnitude 3 and the direction is positive x direction, because whenever you are giving any vector, you are requiring to give two things out of the vector. One is magnitude, one is direction. Right? Right? Now similarly, if I say a boy walks, a boy walks 5 meter west. Okay, a boy walks 8 meter north. How you can represent it in terms of Cartesian? So very simply we can do. So our boy walks 5 meter west. So basically he walks 5 meter in negative of I direction, isn't it? Negative of a vector concept. If I cap is a vector in the direction of positive x, so minus I is a vector in the direction of negative x, isn't it? Okay. Okay, so this will be obviously minus 5 I cap. This is obviously minus 5 I cap. Now a boy walks 8 meter north. So what is it going to become? So 8 meter north, that is, it is going to be 8 J cap. 8 J cap. Now one more thing. One more thing. Let's observe. Now if I say a boy walks, now if I say walks, a boy walks 4 meter east and 3 meter north. 3 meter north. Okay. Now, can you represent it? Can you represent it using the Cartesian form? See, whenever this is what we call as the Cartesian form of a vector. Whenever you are representing a vector with the help of orthogonal unit vectors, that is nothing but the what? That is nothing but the Cartesian form of a vector. Now, can you represent this in Cartesian form? Please try to do that. Can you please try that? how we can represent this in Cartesian. So, sir, very simply, see, a boy walks 4 meter east. Okay. Now he walks 4 meter east. So let's suppose he started walking from the origin. So he walks 4 meter east. Okay. Then he walks 3 meter north. So he goes like this. Okay. He goes like this and he reaches this position. He reaches this position. Now please understand this. Please understand this. Now if I ask you, how much is the displacement? Right away, you are going to say that this is going to be the displacement, right? Okay, let's try to think this way. This is going to be the displacement, you would say, sir. That is 5 meter, isn't it? Displacement that is 5 meter. Okay, now please understand this. Now, if you are representing this vector in Cartesian, how you are going to write it? Let's suppose d vector. So 4 meter east. So the boy moves 4 meter in east direction. So 4 I cap. Then he moved 3 meter north. That means 3 j cap. If he would have moved 3 meter south, you must have written minus 3 of j cap. Okay? Okay? Now, very interesting thing. If you observe, so if I say, now please understand this, can we take up one thing from here? Please observe. So, sir, if this is the d vector, this is the d vector. So, d vector, this is 5 now. I wanted to show you this. So, this is 5. Now, do you agree? Do you agree that if you compare this, so this is obviously going to be 4 and this is obviously going to be 3. This is obviously going to be 3. And if you now refer to what we have learned in the resolution, do you agree to me? Do you agree to me that this, when I write d vector is equal to 4 I cap plus 3 j cap, 3 j cap, this is nothing but the component of d vector in x direction, isn't it? Component of d vector in x direction, isn't it? Okay, okay. And this is the component of d vector. Do you believe it or not? Component of component of d vector in y direction. Okay. So basically, when you are writing the Cartesian form, if you compare this both things, both concepts, so see, 5 is the resultant of this 4 and 3. And if you see that 5 is the vector, if you take the component of this vector 5 in x and y direction, you are going to have 4 and you are going to have 3, right? So whenever you are writing the vector in Cartesian, you are taking the components of the vector in x and y direction, and then you represent the vector in in the Cartesian using those components. Are you getting my point, beta? Are you getting my point? Now, if you understand this thing, if I say a vector is there, let's suppose ax I cap. See, very, very important information I am going to give you. So ax I cap plus ay j cap. Ay j cap. Okay, so this is what we call as the Cartesian way of representing a vector. So what is going to be? So if I represent this vector here, so if this vector is A, this is your A vector. Now, do you understand this? That this is going to be your AX only, horizontal component of this vector. Okay, okay. This is going to be AY only. This is your AY. That is the vertical component of the vector. And let's suppose this is making an angle of theta from here, So, sir, if we want to have the magnitude of this A vector, what is the magnitude of this A vector? So sir, obviously it is going to be root over ax square plus ay square. Sir, how come sir? Sir, ax is a sine theta. We know from the resolution. Ax is a cos theta. Ay is a sine theta in magnitude. So what is going to be ax square plus ay square? It is going to be a square only. So when it is going to be a square only, the magnitude of this a vector is going to be under root of square of the x component and the y component, that is the component which is attached to I cap, which is attached to j cap. You can square them and you can get the magnitude of this vector. Okay, now what is the important point? So if any vector is given by, if any vector is given in the form of a Cartesian, right away you can get its magnitude. Okay, and now what about the direction? So what is going to be the tan theta? So if I write this tan theta, hello mindset, hello my dear. So tan theta is going to be ay upon ax from this triangle. Are you getting my point? Tan theta is going to be ay by ax in this triangle. Understood, beta? So from here you can get theta also. Okay. So if you have any vector given in Cartesian, right away you can find the magnitude of that vector and the angle it makes. Clear? I hope this is fine to you. So see, let's suppose we are having a vector. Now let's try to apply this. So we are having a vector. Let's suppose the A vector is the 5 of I cap minus 12 of j cap. Now you give me the magnitude of this vector and the angle it makes from positive x-axis. Angle it makes from positive x-axis. Can you tell me that, beta? Please go for it. Let's try to see if we can do it or not. See, we have to be careful here. Let's try to do that here. So how we got to do this? That's very simple. So firstly, we want to find the magnitude of it. So if we want to find the magnitude of it, what we can do? So magnitude is going to be the 5 square plus minus of 12 square, sir. So this is very easy, sir. This is very easy. So what we are going to get, sir, from here? So what is going to be the option? So 5 square, that is 25, and this is going to be 144. So 144 plus 25, that is 169. 169, that is going to be 30. So the magnitude of this vector A, okay, you can say, or you call it resultant also, because ultimately these are two vectors in two different directions added. So this is going to be the 30. Now please be careful with the angle. Now see, normally students, what they do, they randomly apply the formula, sir, ay upon ax, and get the wrong answer. See, you have to apply the concept that you have learned. Okay. So sir, how we are going to apply that concept? Now please observe. So now if I draw this vector, let's suppose this is your x, y. Okay, so obviously this is minus x and this is minus y. Now this is 5 of I cap. Now we understood that whenever a vector is written in Cartesian format with I, it is the component of this vector in x direction. With j, that is the component of vector in y direction. That is the component of vector in y direction. So how we are going to do it? So see, this is going to be 5 of I cap. So this is 5. Okay, 5 in positive I direction, positive x direction, and minus of 12. So that is 12 in minus j direction. So this is going to be 12. This is going to be 12. Now, if this is 5, this is 12. Where is going to be your A vector? So your A vector is going to be here. This is going to be your A vector, right? Because if it is 5, it is 12. This is going to be your A vector, right? This is going to be your A vector. Now, we need to find, so I'll have to make it like this. Okay. Now we want to find the angle from positive x. Angle from positive x. So let's suppose this angle is, let's suppose alpha. Let's suppose this angle is alpha. Now can I say that tan alpha is ay upon ax, that is 12 upon 5. Now don't use minus 12 upon 5 here because I am taking the magnitude, because I have understood that alpha is from here. So 12 upon 5. So now from here we can get, now from here we can get what? Now from here we can get the value of alpha. Now whatever value of alpha you are getting from here, whatever value of, so we can get the alpha is equal to tan inverse 12 by 5. No worries, sir. No worries. Now remember the angle when they are asking from positive x-axis. So what is the angle when you see it from positive x-axis? When you are seeing it from the positive x-axis, it is going to be how much? 360 degree minus alpha. 360 degree minus alpha. So see, whenever that, see, you must have understood what is the Cartesian. What do you mean by the Cartesian coordinates vector in Cartesian? So whenever you are representing a vector with the help of orthogonal unit vectors like I cap, j cap, k cap, or the combination of theirs, okay, or the combination of theirs, you can say that that is your vector in Cartesian. That is going to be your vector in Cartesian. Do you get my point? Right? Okay. Now the second thing, if a vector is given in a Cartesian, basically you are having the vector presented in the form of its component in x and y or z direction. Are you getting my point? Third point, that whenever you have a vector in Cartesian, you can have the magnitude of it right away. You can have the angle. You can see the angle also in a go, right? So what if it is in 3D? Now let's talk about 3 dimension. Now if I talk about in 3 dimension, if I talk about in 3D, so in 3 dimension, that means the vector is having components in all 3 direction, or it is the, it is made up of the vectors in all 3 directions. Okay. So how can I write? So a vector is going to be axi cap. Let's suppose a y j cap plus a z k cap. Az, k cap, right? So this is the vector. So what is going to be ax, ay, az? So these are the components of this vector a in x, y, and z. So if you want to see the magnitude, so how can we have the magnitude? So we are going to apply the same funda. Ax square plus ay square plus az square plus az square. So what about the angle? So angle you can see in a two-dimensional plane. Okay. So you can see the angle from x, y, and z. So that what we are going to do with the help of vector product. That will be more easier to do. Okay. Okay, so how to use the unit vector, how we have this. So I hope it is clear to everyone. And what other use of unit vector is this? So I'll just give you one question. Just with the help of this question, you can understand the use of the unit vector as well and the Cartesian thing as well. Let's try to solve this one. Okay. So guys, all these things I have taught very detailed manner on this channel. So if you want to see these things in very much details, okay, then you can go to those sessions and can watch. Right now, please try to do this. Now, how we can solve it? So see, using this question, you will get the idea about how to use the unit vector. So see what it says. So it says find a vector having the same magnitude as that of the b vector. So what is going to be the magnitude of the b vector, sir? So it is given in the Cartesian. So magnitude is going to be 7 square plus 24 square. So this is going to become 25, 7 square plus for 24 square. So this is going to be 25. Are you getting my point, beta? This is going to be 25. Okay. Okay. Now C. So let's suppose we have that vector C. So magnitude of the C is now found. Now to represent any vector, we also require its direction. Now it says that this is parallel to vector A. So when it says that it is parallel to vector A, what does that mean? So parallel to vector A, so that means it is in the direction of A. And in physics, I told you that which vector, what is there to give you or to represent you the direction. So the direction is given by the unit vector. So how can we represent the C vector? So C vector is going to be the magnitude of B and direction of A. So the direction of A is given by A cap. Understood, beta? Understood. So what is going to be the A cap? Now see how we can get the A cap. So A vector we are having. What is the A vector? So this is 3 I cap plus 4 J cap. Okay. So what is going to be the A cap? This is going to be vector A upon magnitude of A, isn't it? Isn't it? So what is going to be the A cap? So this is going to be 3I cap plus 4 J cap upon root over 3 square plus 4 square, right? 3 square plus 4 square. So what is going to be A cap? This is going to be 3I cap plus 4J cap upon 9 plus 16, that is 5. So it is going to become 3I cap plus 4J cap upon 5, right? Upon 5. So I hope it is fine to everyone, right? Please tell me. Yes, sir, absolutely. Absolutely. So what we can do, sir, we can put this back. We can put this back here. So when we can put this back here, so we can have the C vector is going to become 25 into A cap. So A cap is going to become how much? So we just have calculated it. So it is going to be 3I cap plus 4J cap upon 3I cap plus 4J cap upon 5. Okay. So this is going to be C vector and this is going to be 5 3I cap plus 4J cap. Understood, beta? Understood. I hope it is fine to everyone. Okay. Okay, so now please understand it. So this 5, how can we multiply it? So sir, this is very simple. See, whenever a scalar quantity is multiplied with a vector quantity, the result is going to be a vector quantity. So 5 multiplied with 3I cap plus 4J cap, this is going to be 15 of I cap plus 5 4, that is 20 of J cap. I hope it is fine to everyone. Right, beta? I hope this is fine to everyone. Okay. So see, simply from here you understand the use of the unit vector, orthogonal unit vector. What is the use of orthogonal unit vector? That is also, I hope, is clear to you guys. Okay. So I'll just uh, take 1 minute. I'll have to change the slide also because the pages in this slide is completed. So just give me a moment. Huh? Just give me a moment. Okay, so sorry because see, the slides were completed. So it's been a long session. Uh, Already some 3 hours, 30 minutes, 3 hours, 20 minutes are already happened in this session. So no worries, we'll complete the vector. Okay. So, see, I hope that we have understood till now the use of the vectors, Cartesian, and how we can deal with, unit vector, orthogonal unit vector, how we can represent a vector using orthogonal unit vectors, how can we use a unit vector to represent any other vector, right, with the last question. I hope that is clear to everyone. Okay, that is clear to everyone. Now, let's proceed from this point. Now, let's proceed from this point onwards. Okay, now please understand this. Now let's talk about the addition. So I'll just give you. So this is very easy, extremely easy thing. Addition of vector. See, vectors are very easy to be added. Vectors are very easy to be added in the Cartesian form. So addition of vector in Cartesian, addition of a vector in Cartesian. So how we can add a vector in the Cartesian form? Okay, so please understand this. So we have a vector. Let's suppose a vector is ax I cap plus ay j cap plus az k cap, right? Az k cap, and b vector is bx I cap, okay, byj cap, and bz k cap, bz k cap. So how you are going to do the addition of vector and Cartesian? So we learned, so we can add the vectors. We can add the vectors using, you know, law of parallelogram. We can add using the law of triangle. Okay, we have seen those things. Now we are going to see whether how we can do addition of vectors when they are given in the Cartesian. Now please understand, it's so very simple. See, so when two vectors are added, you are going to have a resultant, let's call it C vector. Now if I add these two vectors, what is going to happen? If I add these two vectors, see, simply, very simple, you need to add the I components, okay? You need to add the Y components, and you need to add the Z components. You need to add the Z components. So, beta, simply when you are adding two vectors in Cartesian, just add the I factors, the J factors, and the K factors. Okay, and the K factors. Very simple. Very simple. There can't be anything more simpler to it. Isn't it? Okay. Okay. So let's do it once. So if we have, let's suppose, I'll give you something. Okay, let's do one thing. Let's do addition and subtraction of these two vectors. Okay. So through Cartesian, it is very easy. Why Cartesian is so much in use? So Cartesian is used because in Cartesian, it is very easy to operate in 3 dimension and 2 dimension. Okay. Now please go for it. Please go for it. Very simple. Very simple. So I want you to give me what, sir, you want us to give. So I want you to guys to give me the, I want you to give me the addition of these two vectors, that is a vector plus b vector, and a vector minus b vector. Can you please try to give it to me? Can you please try to give it to me? So, sir, simply, very simple, sir. So, when we are doing a vector plus b vector, sir, so we need to add the I components, we need to add the j components, sir, we need to add the k components. And when we are doing the subtraction, sir, we need to do a minus b, that is 4I cap plus 3j cap, okay, plus 2k cap. Very easy, sir. Very easy. Okay. Now, guys, again, I am suggesting you. So, see, there are a lot of kind of questions that can be, made from this particular topic. So it seems very simple, and it is also very simple. But like to understand this, like what kind of different questions can be asked from here. Okay, so I suggest you to watch the session of mine on this channel. So I have explained the vector addition in Cartesian completely, and we have solved a lot of questions there also of different kind. Okay, So I'm not taking up the questions here, okay, because see, we want to revise the whole vector in this session only, okay. So you can take up questions from there. That is your duty to do, okay. Okay, I hope you will be able to do that, right? Okay. Now let me move to the next concept, which uses the vectors in Cartesian and the addition of the vectors. So there is one very important concept of the position and the displacement vector. Okay, position and displacement vector. Please understand, it's very, very simple. Very, very simple. Displacement vector. Okay. So basically, what is this position vector and what is this displacement vector? So it is a very important thing in physics. So why, sir? Because see, there are many, uh, so like particularly if I give you example of moment or turning moment or torque. Okay, so in torque, what happens? What is the torque? So when a force is acting about some axis or some point which have the effect of rotating that point. Are you getting my point? Which have the effect of rotating that point. That is called your torque. So in physics, like this position vector and displacement vector is quite very useful. Okay, to give you, many physical quantities. Okay, like torque, like the linear velocity, like moment, all those, right? Okay. Okay, sometimes it is used in electricity, current electricity also. Now, what do we mean by this position and displacement vector? Now, please understand this. So, let's suppose, let's take this x, let's take this y. Now, obviously, as the name suggests, the position vector gives us the idea of the position of some vector, okay, of some point. So let's suppose there is a point A. There is a point A here, and let's suppose the coordinate of A is 2 and 3, okay. 2 and 3. Now we understand that when we write the position of this point A as 2 and 3, so this 2 is the position along the x and 3 is the position along the y. Along the y. Now please understand this how we are going to represent the position vector. So this 2 and 3 coordinate, it is basically 2 in x and 3 in y, and we already come to know that movement in x and y or anything in x and y we can represent in the form of Cartesian as well. Now see what is going to happen. What is the position vector? Now, if I join this A from the origin, okay, so any position is always described with the help of some reference, okay. You cannot explain any position without any reference. So, for us, the reference we are going to take is the origin, okay, 0, 0. Okay, so let's call it R1 vector. So, R1 vector is the position vector of A, okay. So this can also be represented as R1 vector position vector of A is equal to 2 I cap plus 3 J cap. Now I want to ask you guys one thing, that using, if you have the coordinate of some point, will you be able to describe that coordinate in the form of position vector using the concept of the Cartesian? Will you be able to do that? Okay, very, very simple. Like for example, if I say there is another point that is B and its coordinate are 6 and 8. Let's suppose 6 and 8. Now, will you be able to describe it in the position vector? What is going to be the position vector in terms of Cartesian or in the form of Cartesian? Please tell me. So obviously, sir, we can do that. So how we are going to do that? So sir, the component is 6. That means it is 6 of I cap plus 8 of J cap. So it must be somewhere. It must be somewhere here at the B. So let's join it with the help of another position vector. So this is going to be R2 vector. Okay. So simply the position vector helps us. Simply the position vector helps us to determine the position of any point. Now, sir, what is going to be the displacement vector? Now, please listen to me very, very carefully. See, see, this is very easy to know also. Like displacement, sir, we understand that this is the shortest distance. Displacement is the shortest distance between 2 points. Okay, between 2 points. So if I say what is the displacement between A and B, then you may obviously say that this is going to be the displacement. Okay, so this AB is nothing but your displacement vector between A and B. This AB is going to be your displacement vector between A and B. Okay. So, sir, how we can sort this out? So, see, very, very simple. So, again, we just have seen the law of triangle. Okay, so R1 vector afterwards, let's keep it as AB vector only. Now, from the law of triangle, can we like see two vectors, R1 vector and AB vector are given by two sides of the triangle taken in the same order. Then the resultant will be given by the third side taken in the opposite order. Please answer me. Okay. So R1 vector plus AB vector, this is going to be equal to R2 vector from law of triangle, isn't it? From the law of triangle, this is going to happen in this way. Obviously, sir. So from here, can I write? See, AB vector is equal to R2 vector minus R1 vector, right? Okay. So you get a pattern also. Do we get a pattern here? What is the pattern, sir? So whenever we are finding the displacement vector between two positions, you are going to have it by subtracting the initial position vector to the final position vector, isn't it? So AB vector is R2 vector minus R1 vector. So see, R2 is the position vector of B, R1 is the position vector of A. So whenever you are finding the displacement vector between 2 points, you need to subtract their position vectors. Okay, their position vectors, that is final position vector minus initial position vector. I hope it is clear to everyone, isn't it? Okay, do you agree? Okay, right. So now let's try this. Let's try to have one question. I'll just so that this thing is somewhat settles in your mind. Now, let's try to do this. Please try. So now how could we do it? So see, very simple. A particle whose speed is 50 meter per second moves along the line from A and B. Find its velocity vector, okay, in the form of A I cap plus B j cap. So what we need to do here? So we need to find the vector in Cartesian. So how we can do it? So see, velocity is a vector, right? So particle, so we need to find velocity. So velocity is a vector. Now, please understand this. So as I say always, so whenever we are having a vector is always have two things. One is magnitude, one is direction. Now, the magnitude of velocity we call it as what? We call it as the speed only. So this is going to be 50. Okay, and what is going to be the direction of this velocity? So what is information given? So it is moving along the line from A vector and B vector. It is moving along a line from A vector and B vector. So if I represent AB vector here, so let's suppose this is X, this is Y. So this is your A point, this is your B point. Okay, coordinates are mentioned. Now please understand this is going to be the displacement vector of AB now. This is going to be the displacement vector between A and B. Yes, sir, of course, this is going to be the displacement vector. Now, please understand this. So, this happens to be, see what is written. See, now combine concepts. So, a particle whose speed is 50 meter per second, that is magnitude we are knowing. Find its velocity vector when it moves along the line from A and B. Okay. So this vector AB is also the direction of the velocity. Now, what gives the direction in physics? Sir, we use the unit vector. Now, can we write it like this? So this is going to be 50 into AB cap. 50 into AB cap. Do you agree? Yes or no? Yes, sir. So this is going to be 50 into AB cap. So AB cap, what is AB cap? So see, right away we can do. Okay. Now what we learned, sir, displacement vector, whenever you are finding between 2 points, you do the position vector of the final position minus position vector of the initial position. So see how you can do it. See, simply you subtract the x factor, you simply subtract the y factor. So 9 minus 2 will become 7 of I cap. See, right away I am doing. A coordinates are 2, 1, B coordinates are 925. So simply subtracting the x component, simply subtracting the y component. So y component is 25 minus 1, that is 24 j cap. Okay. So this is not AB cap, this is AB vector. Now what is AB cap? So AB cap is going to be, sir, AB cap, we know it is unit vector. So unit vector is AB vector upon mod of AB. AB vector upon mod of AB. Right. So what is going to be the mod of AB? It is going to be 7 square plus 24 square. Right. So from here we can obviously get this. So this is going to be 50 upon, so 7 square plus 24 square, that is 25. 7 square plus 24 square, that is going to be how much? This is going to be 25, isn't it? This is going to be 25, right? So we will be getting, sorry, like this, 7 I cap plus 24 j cap. So this is going to be 2 times 7 of I cap plus 24 of j cap. I'm sorry. I hope this is clear to everyone. Is it or isn't it, Bida? Is it or isn't it? The live students may respond to me. Okay. Now, till now in this session, what we have completed with, we have now completed with position and displacement vector. And again, see, we have solved some beautiful questions in the main session. This is the revision session, complete session in vector. So I am trying to give you like a whole thing together, whatever we have dealt in the vector. Okay. Okay. So if you haven't watched those sessions, okay, you can go and watch them. If not completely, you can, if you have watched this session, okay, there's no use of, like, there is no need of watching those sessions completely, because on this session I have given this concept. I haven't left a single concept till now, okay, but I have now have to leave a few concepts, because see, when we go into the vector multiplication, I already have done the vector multiplication one shot. Okay, so that is there. So I'm just going to give you a little bit brief of the vector multiplication, but that is already some one shot session is there in multiplication. Okay, so there is no point of going through that here. So, but I'll just give you a small reference, okay, of the multiplication. See, whenever two vectors are multiplied, so see, whenever two vectors are multiplied, if the if the result if the result is a vector, so I'll just write it like this, C and like this. See, there are some physical quantities when they are multiplied, they themselves are the vector, and when they are multiplied, they sometimes yield a scalar quantity. Like for example, when force is multiplied with displacement, you get the work done. Are you getting my point? And work done is a scalar, right? Now, few physical quantities, when they are multiplied, even though they are vector, the resultant is, or the result of the multiplication lead a scalar quantity. This is what we call as the scalar product or dot product. Okay, this is what we call as the dot product. Okay, simply. Now, if two vectors are multiplied and the result is vector, so this is what we call as the cross product. This is what we call as the cross product. Very, very simply. Very, very simply. Understood, Buddha? Understood? Okay. Now, please understand this. See, I'll just write it like this. Now, if I write A vector dot B vector, that is dot product of this two vector, we are going to get an scalar quantity. So, a scalar quantity, that is the quantity which do not have any direction. So, if the angle between two vectors is theta, the dot product is going to be AB cos theta. Very, very simple. Now, please understand this. So, if two vectors, we are going to have the cross product. So, see, now this is going to yield a vector. This is going to be yielding a vector. So, if we talk about the magnitude of it, if we talk about the magnitude of it, it is going to become AB sine theta. Okay, AB sine theta, and it will also be needing some direction. Okay, and direction is given by the unit vector. So I'll just write n cap in the end. Why n cap? Just to tell you this, that whenever we are having any vector, vector has two things, magnitude and direction. Okay, so whenever you are doing the cross product of two vectors, you are needing to see the magnitude as well as direction. So AB sine theta is the magnitude of the cross product, and n cap is the direction. N cap is the direction. So from where we get this n cap? So see, two information. Okay, I'm not going to discuss it in much detail because we have, I think, a day before completed this thing. So you can please check out that session. Two things. First thing, this direction is perpendicular. This vector is going to be perpendicular to both A vector and B vector. This will be perpendicular to both A vector and B vector. And secondly, so if it is perpendicular to A and B, there can be two possible directions. Okay, an axis, let's suppose two vectors are there, so there will be an axis that is perpendicular to both the vectors, right? But it can be both ways. It can be both ways. So which way? This is from the right hand thumb rule. Right hand thumb rule. Okay, so whether let's suppose let's suppose that your any direction you got, so you can get the two directions. So if you are getting the direction of this product, let's suppose, so it could be in y direction. So your question is, it is positive y minus y. So this positive and minus you are going to get from right hand thumb rule or the screw rule. Okay, so from where we can learn the right hand thumb rule. So as I said, beta, I have discussed in very much detail of this multiplication of vector. I think I have taken 2 sessions of it. So from here, I have comprehensively dealt with all these things. So right hand thumb rule, you can go and watch there. Okay, just a simple information I have given you. So in the both cases, the theta is going to be the angle between the vectors. Okay, I hope it is fine to everyone. Now, very important thing. Now, very important thing. Now, let's suppose we are having two vectors. That is a vector. Let's take some 2 I cap plus 3j cap minus, let's suppose, 4k cap, and we have another vector. We have another vector, that is b vector, and this is I cap minus 2j cap minus 3k cap. Let me have consider two randomly two vectors. Now I have to do, see, I want to do the scalar product of it. See what we have to do. See, very simply, in short, I am telling you. Okay, so why it happens this way, all this thing you are going to, if you want to watch completely, if you want to see that how it happens, okay, what is the reason, how, or what is the proof of it. So everything I have discussed in the previous session, you can just go and watch my other sessions on this channel regarding the vector multiplication. You'll get everything. So see, two vectors when I multiply, so it is going to be, see, simply, see, I component multiplied with I. Okay, J component is going to multiply with J. K component is going to be multiplied with K. See, simply plus 2 into plus 1, that is 2, plus 3 into minus 2, that is minus 6, minus 4 into minus 3, that is going to be plus 12. So this is going to be how much, sir? This is going to be 8. So a scalar product of this two vector is going to be 8. So sir, is there only this much in a scalar product? No. There are many things. What is the angle between two vectors? You can get uh, through this dot product thing. So what is the angle any vector makes from x, y, and z in 3D? In 2D, we can very easily do with what we have learned. Okay, but in 3 dimension, it is slightly difficult. So there also you can use the concept of what, the dot product. All those things I have taken care of in the previous sessions of vector multiplication. So do what, you will get more questions of it. Now if I want to do the if I want to do the cross product of these two. Now please understand this. This is very easy. We are going to see the shortcut method. See, see how we are going to do it. So we are going to use the determinant method. See, I am going to give you a very short thing. So this is going to be like this. See, very simple. So I'll be using the determinant method right away. So how? So everything I have explained. Okay. Just watch those sessions if you want to have the more information. As I said, this is just the revision session, and already I think some 4 hours are going to finish for this live session. So this is going to be C. And also remember, this is not, you cannot reverse the order in cross product. A cross B is not equal to B cross A. So this is going to be 2, 3, minus 4, 1, minus 2, minus 3. Okay. Simply, see, this is what we call as the matrix. Determinant is, there is the topic of mathematics, that is the matrix, and in those matrix we also find something known as the determinant. So it is going to be like this. It is going to be like this. Now what we can do, sir? What we can do? So we can simply find, see how we can do it. Very simple. See, I cap. Okay. Now see, when we are writing I cap, so there are some numbers, two numbers written beneath I cap. Don't see them. See the remaining four. So what are the four left? 3 minus 3, multiply them. This will become minus 9, minus 4 minus 2, that will become plus 8. Minus 4 minus 2, that will become plus 8. So this is going to be your I cap. Okay. Now see, you started with plus. You started with plus, then you go to the J. Then you will write minus of j cap. Now, what is below j? This is 3, this is minus 2. You see this 2, these 4. Okay, and do the same. 2 minus 3, that is minus 6, and minus of minus 4, so it will plus 4, plus k cap, plus k cap. Now see, sequence plus minus plus. So this is going to be the k cap. K cap is 2 minus 2, that is minus 4 and minus 3. Okay, minus 3. So this way you can get this obviously. So if you do it, so let's sort this out. Okay, let us sort this out. So this is going to be minus of 17 I cap, and this is going to be plus 2 j cap, and this is going to be minus 7 k cap. So this is going to be the cross product. Okay, so using this determinant method, the directions are also taken care of, isn't it? Isn't it? So very very simple, sir. Very very simple. Okay, so see, there are a lot of things from the cross product that you can get. Okay, like the torque, like the moment, and there are other, other things also from it. But this is the basic. If you want to multiply two things, like for example, now see, like if you want to find the torque, so remember torque is r vector in cross product with the force vector. So if r vector is given, force vector is given, you can simply find the torque. Okay, if velocity, linear velocity is asked and angular velocity is given, remember this is omega r cap. So see, in cross product, the order is also very important, because in cross products are not commutative. Okay, okay. So I am hoping. So see, again I am saying whatever I have taught. So vector is a big thing. Okay. See, if you don't have good understanding in vectors, what happens that we feel difficulty in throughout the physics. Okay. So in very much detail, we have completed the vectors in this channel. Also, now today's session, I have give you one short session, all the concepts of the vector with some powerful and good questions which help you gain the concept. But I suggest you one last thing here, that so you need to do more question of each of the topic what I have dealt here in today. But I have completed all the topics majorly, right? There are a few things like, sir, what is the zero vector? Zero vector will be used in the cross product. So zero vector is something which is having magnitude zero, but it is not directionless. It can have arbitrary direction, right? And it is basically used in the cross product. So when two vectors having to do go for the cross product and the result is zero vector, so you can write zero I cap, zero j cap, zero k cap. So all these things I have taught in the full session. Okay, so what I suggest you that you go to those sessions. No need of watching them completely, but at least you can pick up the question, right? And for the product multiplication, vector multiplication, you can see some sub concepts like finding the angle between two vectors using dot product, right? Finding the angle of a vector with coordinate axis, resolution of a vector in a scalar and vector form, right? All this thing, what is it's scalar product of a vector product. All these things we have dealt there. So I hope that some things you can cover from those sessions also. Okay. So guys, to all the students who have watched this video, thank you very much. I hope you enjoyed the complete session of this vector. And if you haven't subscribed yet, I request you to subscribe the channel so that we can come with more conceptual, more interesting, more good videos to you guys. Okay. So on this channel, we are running biology, physics, and chemistry is also very soon is going to start. Okay. So all the subjects we are trying to complete for you guys as soon as possible, so that you can go ahead for your NEET examination. You can boost your preparation. Also, 75 days challenge is also there. We are doing daily questions also. Okay, so everything we are doing is in the direction of your right path towards the NEET examination. So please like the video, please share it to your friends, please subscribe the channel if you haven't yet. So with this, thank you very much. Have a good day, and we'll see you in the next session.